Androids Baker. It's the Androids Baker. It's the Androids Baker. Androids Baker. It's the Androids Baker.
It's worth, of course, looking at the stage that I'm standing on, mentioning our partner, Google, here for building the stage for us, for coming out, and they're going to do some incredible things today at the show and tomorrow, and I'll talk about that a little later. But thanks so much for that. We're really, really happy to have them here with us. So there's always a group of special people I have to thank every time. Our program committee, let's give them a round of applause. They worked really hard. They really do donate an incredible amount of time to you and the community, to slogging through several hundred submissions and working and looking at the background, looking at people's blogs, what they've done before. It's really a process, and I really am so appreciative of these people who are just fantastic. So happy to have them. If you haven't downloaded the app, there's a QR code. That's the sort of official DroidCon app. If you decide you don't like it or don't want to use it, that's fine. There's also the Confetti app that you can find, and I think, I don't know if John O'Reilly's here this morning, but I know I gave him API access to Sessionize, so that should be updated too. For the shameful, godless heathens out there who need this code, I will begrudgingly do that. Just quietly, stealthily. Yeah, exactly. Hold your phones down here. Don't make eye contact with people next to you. Hang your head in shame afterwards. But, we have something for you too. Anyway, so just one little thing you should know, there's just this fun little feature. There's sort of like this group chat app, this individual chat thing. You can scan, not your badge, the QR code on your badge, but you can scan the one that's your ticket, but you probably don't have with you, which is fine. So if in there you'll enter this little code, DCLDN25, that gets you into the chat. You can use it or not, just remember the code of conduct, be nice. All right? So let's just talk really quick about what's new this year at DroidCon London. And I'll talk about some things that are coming up. So last year, this is sort of new-ish. Last year, we sort of rolled this out, kind of tested it here in London, which is sort of this, what we call the Unsolved Unconference. And I think everyone knows that, we've been doing these DroidCons for decades now. And I think we all know that some of the most valuable things that we all get and take away out of the conference is, of course, the sessions are fantastic, but it's also the discussions that happen during the breaks and those chance meetings, and the people you meet in the hall afterwards. And so we thought, at least, how do we take that experience, because we know people are having it, and how do we sort of do that at scale and on steroids? And so we came up with this Unsolved Unconference concept, which is essentially a series, and they run throughout the day. You'll see them on the agenda for the next 2 days. These unconference roundtables. These are not panel discussions, and so we've got some great hosts, some people from the community that have agreed to sort of host and moderate these. But it's basically what it is. It's really about crowdsourcing all the intelligence that's here in the room. Right? So you may have submitted, you may have something to say. Everyone has a perspective. Everyone has experience, challenges they're dealing with, things that have worked, things that haven't worked. And that's the opportunity to come in these unconference sessions, sort of crowdsource intelligence. And so my only advice to you is that if the host or moderator is up there sort of giving a monologue, they're not doing it wrong, you're doing it wrong. It's your chance to pipe and say, I have this question, or I'm asking for a friend, if you don't want to say it's for you. And, come up and also just share your experiences. So we've got those. They're really fun. We've really enjoyed having those. And so we thought, we sort of guinea pigged that here last year in London, and we've been doing it this whole year at all the DroidCons around the world, and it's been really great. So another thing we did sort of, for selfish reasons, because I've been doing this so long that most of my friends and everyone that we all came up with have now moved on to sort of leadership positions. So I said, we want to make sure they can come back and I can see everybody. So we have this Tech Lead Summit. There's also a track. It's really sort of meant for engineering managers, staff engineers, principal engineers, tech leads, senior devs. And this is also similar to the unconference sessions. There you'll see a series of talks. You'll also have some peer level discussions. It's open for everyone. It's not a separate ticket. You can go. Anyone's welcome. If you're thinking about sort of making that leap from IC to managerial roles, I think you'll get some interesting perspectives there. But that is going to be also a new track that's here, and that we'll keep doing that. So look forward to seeing everyone there. Let's talk about conference videos. This has always sort of been a pain point where, we've always been sort of waiting, and then they get posted on droidcon.com, and I'm well aware that experience was never wonderful in terms of the search and finding. So we've partnered up with the fabulous folks here that do all the video recording, and all of the videos will be released on YouTube. There's the DroidCon channel on YouTube. It's easy to find. And in fact, starting today, we'll start releasing videos. So they will be, we won't have everything all at once. They'll be coming out, kind of trickling out every day, for the next few weeks. But that's, I think, so we heard some whoops. I'd like to hear more. Yeah, okay, all right, there we go. So generous of you, so kind. Yeah, so I think that's going to be good. We're happy about that too. So let's talk a little bit about what's coming up next. And of course, before you talk about what's next, you always have to do this retrospective about where we've been. And so there's this old world, and in a way we're still living in this world. It's a world of walls, it's a world of silos, where, even developers had to sort of pick a side. Are you doing X or Y? Are you doing Android, iOS? It's different tools, different languages, different communities. And I think certainly the catch for companies, for anybody, it's you have to do everything twice. And, there was this sort of like newish world after that where attempts to build bridges, this dream, write once, deploy everywhere. And I think, there were some early attempts that were highly flawed. And I think we're living in this world, this newish world where like today, things like Kotlin multi-platform sort of standing on the shoulders of some of those early attempts, at this dream. And so I think we're getting there. And I think that's the world we know. We're still there, making fantastic progress. But there's also this other thing happening right now, and I think we would all agree that we're sort of swimming in the deep waters of this sort of generational paradigm shift, in large part driven by AI. And I've been through a couple of these, obviously with the gray in my beard, you can tell. I've been through a lot of them, these kind of shifts. And, I think that everyone has strong opinions, particularly when it comes to AI. I think everyone's also got an opinion about what that means for us as developers, what it means for our community. I think if you go online, if you're on any kind of social media and LinkedIn, you can't scroll for more than 2 seconds without finding somebody's new, fresh, hot take on what that's going to look like. So I think everyone's asking ourselves, what's next? And when we think about what's next, I don't have an answer for you. I spent a good portion of my 30 years in tech. Part of that was advising companies on this question of what's coming next. Now I can say, sometimes I got it right, and more often than not, I also got it wrong too. I think it's hard to predict everything about what's next. But I can tell you, and I'll save you my predictions about all this, but I will say that I think when we look at where we were before the world of walls and silos and barriers, I think that when we look at what I think the vision of the future is that we're looking at, I think it's less about walls and silos and more about being unified. It's less about fragmentation. I think we're all going to be doing things together. So we're kind of sort of embracing what's next. And I'll show you this little, just kind of fun little video we kind of put together about what we're doing, about what's next. We got 1%. So why am I talking about this? I just want to say this is something we're premiering next year in Berlin. I think it's relevant also for this audience just to mention that. But, when we look at this, we think that in Berlin next year, where we're premiering it, it'll be the largest gathering of mobile developers in the world. And that's what we love. That's what we've been doing since 2009 with you, with our Android developer community. We're always going to be talking about mobile. We want to talk to mobile developers. We want to be with mobile developers. That's where we're at. And I think really what we looked at with this next step concept for next year, again, launching in Berlin, is looking at what's next, building what's next together with all the different mobile communities. So they think this is going to be the largest gathering and it's going to be a DroidCon. You'll see a FlutterCon, you'll see a ReactCon, SwiftCon. We're doing things specific to XR and games, and AI DevCon. I think it's going to be really fun. It's going to be 3 days there, and of course, you're all welcome to come. What does that mean for DroidCon? DroidCon's still going to be around. Little new, fresh kind of branding. It'll be here, and we'll see you all here in London next year as well. But I just wanted to tell you about what's coming up in Berlin, sort of where we think things are headed. So we put together kind of a fun game. You've probably seen some of these signs. We put together this deck of 20 tarot cards. And what we've kind of made a game out of it. The cards are going to be all over the event here today. You can find some with the sponsors, some of those speaking rooms. And for the first 5 people to collect an entire deck of 20 tarot cards, the What's the Next App tarot card deck, you have a literal golden ticket that we've printed out for you to come next year to Berlin and see what we're doing there. So it's a lot of fun. This is just a little sample of some of the cards. All the cards have a QR code. You can kind of see they're all kind of fun designs. There's a little, a fortune or whatever you get in tarot. It's not, I guess, called a fortune, but it's your future. There's that. There's the burnout. We've got one called the App Store Oracle. They're all just kind of funny. So invite you. I've also got here with me a stack. So afterwards, if you want to come up and start building your deck, come and talk to me. I've got a couple here. So enough about that. Let's go back to DroidCon London here. So there's a lot of fun things happening. As I said, we got a lot of great talks. One of the things that we're going to do is our usual Pindroid. Who's played Pindroid in the past? Okay, a couple of people played it. So we've got Ben Cadell here, and we're going to He's going to give us a little intro video about what Pindroid is all about.
Hello, Lucy. My name's Ben, the creator of Pindroid. And I bet you're wondering what Pindroid is. Well, let me tell you. Pindroid is the world's greatest conference scavenger hunt game. The aim of the game is to get pins. Lapel pins, enamel pins, pin badges, whatever you call them, these things.
Throughout the duration of the conference, you'll try to acquire as many pins as possible. Of course, you get to keep the awesome pins, but pins also means points. You can easily see each pin's value on the Pindroid website.
The person with the most points at the end of the competition, usually the end of the conference, wins real-world prizes, like Lego sets. So, sounds good. How do we get in?
Head to the website pin-droid.com and find the box with the text "Register for Pindroid here." Follow the link, pick your visible display name, and submit the form.
Now, you're a player, and any pins you find will be connected with your account on the system.
Pins will be hidden throughout the conference location, anywhere that you as an attendee can access, except for, of course, stages. When you find a pin, it's yours, but the paper bit is the important part. If you find a pin without the paper slip, it's not part of the game, and therefore is meaningless. When you find a pin, scan the QR code.
Follow the link, and if you want to, submit a nice little selfie with you and your shiny new pin. You can always see your current points and standing on the leaderboard page. Pins can also be given to other players, in the case that you've already got that pin or just want to be a nice human being. Gifting pins, as long as the receiver scans the pin, will give you some extra points. But not them. They don't get anything but the lovely pin itself, of course. An individual pin can only be gifted once on the system. There's also a bonus to anyone that has owned at least one of each pin in the collection. See the website for more details about full collections and the benefits. It's important to note that gifting a pin will not remove it from your collection, but be warned, it will add it to the receiver's collection. Pins can also be won during publicly announced mini-games that will be played throughout the conference. To get announcements about these mini-games and all manner of clues and notices, make sure to follow the Pindroid account on Blue Sky or on X. And that's Pindroid. More information can be found on the How to Play section on the website. And make sure to keep an eye out on the events page too. Good luck to you all. May your pindars be sharp and the pins forever yours.
All right, thanks, Ben. Ben, stand up. That's the guy right there. All right, so just a little bit of preview. What's happening tonight? So we've got a full day planned. We do want you back here at 5 o'clock. We've got the live broadcast of the Android show. We've got a leadership keynote from Google that's happening, which will be the first part. I think if you were here last year, you sort of remember this broadcast is going out live at 5 o'clock. There's some live content that's going to be broadcast here from the stage. There's also some pre-recorded content, which you'll be able to, of course, see on the screens and be part of. So we've got, that's sort of why it's just me this morning. We've got the keynote this afternoon. Usually it's morning, but we're reversing it because they're broadcasting at 5. Come for that. It's going to be really great. And then after that, there's also a panel discussion. So throughout the day, as you're here talking to folks, as you're in the sessions, you can sort of store up all of the juicy questions that you've been afraid to ask, but now have an opportunity to ask to the Google leadership here. So we've got this panel discussion. Now that'll be moderated by Rebecca, who's going to moderate that first, which will be broadcast live, and then they'll shut off the broadcast, and then it's sort of just us, and then you can ask the questions. So that's going to be great. If any of you remember Chet, may he rest in peace. He's not dead, but he's... It's a little overly dramatic, but he's not with us anymore, which also sounds like he's dead, but he's very much alive. Just talked to him recently. Anyway, there's a couple of rules about these panel discussions that I want you to follow. So these are the panel discussion rules according to Saint Chat. Again, may he rest in peace and also be happy being alive too. So first one is, don't ask about the super secret thing that they're developing that they can't possibly talk to you about because their PR people would kill them and the lawyers would too. So just don't ask about that. You're not going to get an answer. It always comes up, it's like, hey, you tell me about the secret. No, just don't do it. Okay, that's rule number one according to Saint Chat. Rule number two, during the panel, okay, don't say the F word. Don't ask about the F word. Don't even think the F word. What is the F word we're talking about here? Who wants to venture a guess? Yeah, that's good. We had the right F word. I was hoping that it wasn't going to be, something else that was shouted out here. But that's okay too. We're all adults. It's fine. Yeah, so, ask, this is the Android team's leadership here. So this is just, again, Saint Chat, thank you. And after that, we've got a live band coming tonight, live karaoke band, so you can sing with. It's gonna be great. Sorry, I keep choking up. Maybe it's I'm so emotional because you're all here. I don't know, or my throat's dry. The Android Monster Mash tonight. So listen, it's going to be a long day. It's going to be a lot of fun. We're all going to go home really tired, but that's happening as well right after the Android keynote and the panel discussion. Just a little preview tomorrow morning here. We've got then the community keynote on the future of Android, how to prepare for it. Some great folks from the community with our own Anastasia here moderating that. And so that's going to be fun. This is sort of one of the features we've been doing throughout all the DroidCons this year around the world, is asking some people from the community to give us their take. How do they see the future of Android? How do they think you and we and all of us should prepare for that? So that's going to be really cool. That's going to be tomorrow morning. So listen, that's what we've got in store for you today. There is a minor miracle. We're only running 1 minute behind. So everyone get the heck out of the room. Go have a good time. Get some coffee. There might be still some breakfast out there. And just go have a great day. Thanks for being here. How you doing? Yes, I'm gonna get you. See, you were one of the brave ones. I'm gonna get you started with a couple. You two, yeah, here. You're getting a head start on these on the deck here. Huh? Yeah, I know. It's gonna be fun. Hello. Oh, look at it. Yeah. How you doing here? So you're getting. Oh, geez, you're getting a huge head start on these. All right. Oh no, the coffee.
It's my first time here.
Most of what I use.
It's my first time here too.
Hey, good to have you.
What are you suggesting to do here?
You know what? Get on the agenda, go to the sessions, but also take time to go to the Google Office hours. Yeah, and take some time just to chat with people.
Chat with you.
Yeah, do it.
Yeah.
It's the same as the SSID.
Thank you.
Yeah, going on London or something like that. All right, go for it. Yeah, here. We got enough to go around. Running out though. Here you go. Here's getting a head start. And they're all gone. You're the last. All right. There you go. Thanks. Good to have you here. Oh, you know what? Wait. I think I might have found a couple more. Oh, yeah. Got a couple more. Yeah, here. All right. Did manage to find a couple more. All right, there we go. Hey, looking for some cards here. I got the last two. Like, good? Huh? Sorry.
Kina var gratis, men jeg kan kigge op keynote-film.
Inside the school? What? Keynote? Missing? What?
No, it's not missing. I sent you a message on the agenda says the keynote's on 10:30
Tomorrow morning or today?
today.
What? Where on the agenda? I looked at that and I was like,
The agenda. Don't look at the one that's online on the website, on the actual website. That's what I'm saying. Like,
Collect like a pro. Manuel Vivo. 9:35, Manuel Vivo. Go down. 10:30.
Yeah, that's not a keynote though.
It says keynote session.
Oh, fuck's sake, that's
Okay, but it's an order, right? Order, right?
No,
It's-
because it's wrong because I tagged him as a keynote on LinkedIn.
okay, that's definitely not right.
So is Manuel Vivo the keynote then?
There's no the keynote. Okay, is this the one here? Session, George County session.
You need to be way.
Oh, you know what? This must have been, he must have put this on here as a keynote. It's actually,
It's been online. That's how it's been announced, though.
why is it as a keynote there? It's a session. That's also a tag. It's not the type of
Maybe
session.
did it by mistake.
It wasn't us. He's not a keynote speaker.
Yeah, but also it was listed on the speaker card as keynote, by the way.
Okay, so we have to change
It's not just the agenda. It's been announced publicly.
Yeah, but those are the kind of things I'm like, we can see here that like, there's like 6 other sessions going on. It would be weird to have him be a keynote.
I understand that, but this is before. I'm talking about before we even organized the debate slots and everything.
Okay, let's change the speaker cards, yeah? I asked quickly to change the speaker card.
Yeah, it's not a keynote. Okay, the thing is, he must have put that in himself. I didn't even know it was there. Yeah, because we have.
I announced it on LinkedIn today.
Yeah, go kill that post.
Well done, Greg. Okay.
Also man muss einfach so ein bisschen, ja, das man muss einfach mal ein bisschen aufpassen.
Androids Baker. The Androids Baker. It's the Androids Baker. It's the Androids Baker. Troy's Baker. It's the Troy's Baker.
or different legs, and it's going to be using flows and operators to get the data that they needed, in the format that they required. Also, we'll see that most of the time we don't really need to create these streams of data because the data sources that we are using already provide that flows for us under the hood. So whether you are using data store or room or work manager, all that information is going to be already provided by you. And then if we look at the typical application hierarchy, you will see that we have different layers in our application, and potentially all of them are going to be exposing a type of flow of some sorts. And we'll see why this is important, right? At some point in the view model, we're going to have this state flow, which is going to be an observable data holder type. And kind of the main difference there is there is always an item to be displayed on the screen. That's why it requires special consideration. But this is kind of the content that you can find in that talk. But I wanted to finish up with this kind of recap, just to make sure that, okay, we are going to get a flow, right, from different layers of the hierarchy. But we don't know exactly the implementation details of that particular flow. And it could be, made or it could be configured in different ways. So we can consider two different types of flows. We're going to have a cold flow that probably, as you know, it's going to produce data only when it's actively collected. And that block of code that is going to produce the data is going to start fresh for every collector. So for example, if we use the Flow API, here we have this coroutine, this code that is going to emit three different items. It's going to be quite straightforward. And every collector is going to get these three items in order. If we keep using the water analogy, this is like opening the tap. Like every user, every person is going to get a new fresh stream for themselves. It's kind of the analogy when it comes to cold flows. On the other hand, we're going to have hot flows that is going to continuously emit events, emitting data regardless of collectors. So it doesn't matter if there are collectors or not, data is going to be emitted, and maybe if no one's listening, probably it's going to be somewhat discarded. An API to do that could be the mutable shared flow. This is of type int, and then you can emit to the flow, again, regardless of collectors there. Using the water analogy, this is kind of like a river, right? Water is continuously flowing, data is going to be emitted, and if, as a collector, you are interested, you would go to the bank of the river to access that item. And when we talk about hot versus cold flows, there are some APIs that are going to help us achieve this behavior. So by default, pretty much all flows are going to be cold. And then those using the flow builder or different APIs like flow off or as flow. And then if you want to make that flow hot explicitly, you can convert the cold flow to hot with a sharing or stating operator, or simply creating a new flow with the shared flow or state flow APIs. Okay, so now here's the question, right? What type of flow am I getting if I'm subscribing or collecting from the data source or the repo use case? We don't know. And even in the view model, we could assume we are going to get a hot flow because usually we expose a state flow. Depending on how you configure it, it could have this kind of hybrid mode in which it could potentially unsubscribe or stop collecting from the upstream flows if we use something like the while subscribed starting policy. So again, every layer is going to be a different abstraction. We don't need to go into the implementation details, otherwise we could go mad at it. So what do we do? The thing is every layer should be doing the right thing. That's it, right? And while this might be a little bit simple, sometimes it can get a little bit difficult and complicated. And this is like this because every layer knows, or every class knows what they are responsible for. So they should know exactly what kind of caching they need to implement or stuff like that, right? So we don't want other different layers of the hierarchy to make assumptions about how a particular flow is implemented. And in this presentation, we are going to be looking at the UI layer. And the right thing there is to stop collecting from the different flows when the app, for example, is in the background, right? When we are not needing the information to display things on the screen. Okay, so that's the recap. We're going to look at how potentially we could be wasting resources of our device if we don't collect properly. And to do that, like we need to do, again, to quickly look at the UI lifecycle, where we know this is true for both Android and KMP. When the lifecycle is at least started, it means like the UI is going to be visible on the screen. And then when it's resumed and above, it's going to be foregrounded. Otherwise, we don't have the UI on the screen. So looking at how we could look at, for example, think about this problem, let's use a Maps application. We're going to be displaying the location of the user on the screen. And so, like naively, like we could be having some code like this. I have my view model. I have exposing the location of the user with a flow, location updates, and then I'm going to collect in the onCreate. And you can say, okay, like this is probably, you might feel like this might be a little bit of a smell, but if we look at the equivalent compose code, it would mean you have a composable function, I collect from the same flow, and I use the collect_state API. It's going to do the same. For as long as this composable function is in the composition, it's going to collect from that particular flow, even if it's in the background. So we are in our app. The user is actively using it. It's in the foreground. We are getting location updates, and that's all good because we are going to be moving the cursor and the position of the user on the screen. And at some point, the user decides to background the app. And one of the problems here is like we don't know when the user is going to come back, right? But because of our implementation, because of the way we collect it from the flow, we are still subscribing to those location updates, right? And we are going to be either like with an active connection to the location like fused provider, and potentially this could consume a lot of resources from the device if we are not careful. So this might be wasting resources, but also depending on the UI toolkit that we are using, it could be dangerous and it could make the application crash if we try to update the UI while in the background. So how do we fix this problem? Again, the expected behavior is going to be to stop collecting from that flow while the application is in the background. If we are in the activity, we could manually call, start collecting in onStart and then cancel that coroutine in onStop. This could be a little bit annoying because we have to do that for every screen and every flow that we have. If we are in a fragment, things get a little bit more complicated because you need to add an observer to the view lifecycle owner and then have that logic in it, and then like how you set it up, and then the logic to update the UI. It's kind of mixed up together. The responsibility, separation of concerns might not be like working very well there. And then if we are in Compose, it's even a little bit harder. Maybe we need to create the preview states, again, like listening to the lifecycle changes and do something custom. So to alleviate all those problems, we have the lifecycle-aware coroutines APIs. They are stable. They're also part of KMP. We have a bunch of them available for you to use, depending on how much you want to abstract things away. So we have a few APIs. Repeat on lifecycle. This is an extension function on lifecycle and lifecycle owner. And the flow with lifecycle API, which is an operator, flow operator. These are going to be available in the lifecycle runtime KDS artifact. And then for Compose, we have the collect_state with lifecycle API, which is also extension function on stateflow and flow. And this is going to be part of the Compose artifacts. This has a KMP compatible with an asterisk. We'll see in a second, like the caveat here. So let's see the API definition of these functions. So we have repeat on lifecycle. This is a suspend function, meaning that we have to call it inside a coroutine. And then it's going to take a state as a parameter and a block of suspend code, right? A block that is going to be running on a coroutine. And repeat on lifecycle, what's going to do is that every time that the lifecycle is at that particular state, it's going to create a new coroutine and it's going to run block within it. And when the lifecycle falls or below that particular state, it's going to cancel that ongoing coroutine. So what we get is this restarting behavior of running block and stopping the block every time the lifecycle goes above or beyond that particular state. It's a suspend function, so it needs to be called in a coroutine, meaning at some point it needs to resume the execution of the coroutine, and that's going to happen when the lifecycle is going to get destroyed. So how do we use it? So repeat on lifecycle, inside the block, we can collect from that flow. And because here we are using started, it means that the collection is going to happen only when the lifecycle is started. And then if we pass in resume, only while the UI and the lifecycle is resumed, while the app is foregrounded. Using it in an activity could be, lifecycle scope. We create a new coroutine. We call repeat on lifecycle, and inside it we collect. We get the right behavior by default. And then in the fragment, we need to use the view lifecycle owner, not the lifecycle of the fragment itself. But again, be careful because it's a coroutine, right? And when the repeat on lifecycle function resumes, we shouldn't do anything. We have to be careful and not do anything with the UI, with the view, because at that point, it's going to be destroyed. The flow with lifecycle API, it's a flow operator, so it's an extension function of a flow, and it's going to return a flow, generic flow. We are going to pass in the lifecycle and then a min active state, and it's going to behave in a very similar way. Flow with lifecycle is going to have this functionality of subscribing or collecting from the upstream flow when the lifecycle is at least in that particular state. And it's going to stop the collection of the upstream flow whenever it falls below that state. Similarly, it's going to take the started state by default as a default parameter value. Here is the same, right? And then if you pass the resumed min active state, it's going to collect from the flow when it's going to be the UI foregrounded. Very similarly, like you can use it in that way as well, for example, in your activity code. Okay, the other function, the other API is collect a state with lifecycle. This is the API definition with the extension function on flow, and it requires an initial value. If you use the extension function on state flow, you don't need to pass an initial value. It's going to use the initial value of that particular state flow. And this API is going to return compose state, and it's going to behave very similar to collect a state. And it's going to update that compose state every time there is a new emission to that flow. With the caveat here, or with the nice thing to have, that is only going to do that when the life cycle is at that particular state. So in your compose code, it's just like this. It's a one-liner, right? And instead of using collect a state, you use collect a state with life cycle, and you are going to be doing the right thing by default, right? It's only going to update location, and it's going to only collect from location updates when the UI is going to be visible on the screen. So we mentioned that collect a state with lifecycle is KMP compatible, but if you use a different import, and this is the wrapper that JetBrains has on top of the lifecycle APIs, and this is mostly because most of some of the compose APIs and artifacts aren't still supported by KMP. So meanwhile, you could be using that artifact. You might need to import that dependency. And if you want to see some examples of this, you can check John O'Reilly's open source samples, for example, like Confetti or People in Space that is being used there. Okay, so we are going to have these three APIs. And we're going to do a little bit of a recap because you might think, okay, but do I have to use these APIs all the time or not? I mean, the recommendation is, yeah, like it's not going to hurt. If you use them on hot flows in the end, like when it comes to the implementation detail, it doesn't really matter, right? The hot flow is going to be active anyway, but you're going to be you're going to stop the collection when you don't need it. So, why not? It's all good. Even with cold flows, like if it's like a really pure cold flow, you don't really need it either, because cold flows, depending on how they are set up, it could also stop the producer emitting items. And this is true when back pressure comes in. So if you have a producer that is emitting items, but then back pressure is in place and the receiver, the consumer, isn't using the item, then the producer is going to stop and you're not going to waste resources. But you never know, right, if it's a pure cold flow or not. And when these APIs really shine, it's when you are using they are used in a cold flow backed by a channel or a buffer. And this is because like that buffer is going to keep the producer active, emitting items and producing more and more items. And you might think, okay, I'm not using channels that much, or I'm not using the buffer operator. Doesn't matter, right? Because there are some other common operators that they are using these APIs under the hood. For example, like the flow-on operator, it's doing buffering on your behalf. You may not know. And then you might be wasting resources without noticing. So TLDR, use these APIs because why not, right? Like they are very helpful. Okay, let's go through the implementation details of these APIs. It's not just for the fun of it. It's because I think we can learn like many good patterns and things from the implementation details. So we're going to see that every API that we introduced is going to use a different low-level API that you can use on your benefit as well. So repeat on lifecycle is built on top of suspend cancelable coroutine, flow with lifecycle using callback flow, and collect a state with lifecycle previous state. Suspend cancelable coroutine and repeat on lifecycle is going to be the harder one because pretty much the rest of the implementations are going to be using that one with the kind of the base and common functionality. Okay, suspend cancelable coroutine, like there are like many talks, many content about this on the internet, so I'm gonna go quickly through that. But it's the way we have to create a new coroutine and jump into the coroutines world. It could be based on a callback-based API or some other asynchronous code that you might have. And the good thing about this API in particular is that it's gonna benefit from structured concurrency, so it's gonna propagate errors and cancellation as expected. So let's forget a little bit about the water analogy. Let's use coffee and imagine that we have this coffee callback API. We are at Starbucks or whatever, and we have this barista, and we want to get notified whenever we have our coffee ready. So the way to bridge this callback-based API into coroutines world, we can create a suspend function that we call prepare coffee. It's going to return actual coffee. And then we are going to use the suspend cancelable coroutine API. We are going to get the continuation parameter that is going to allow us to control the execution of that coroutine. At this point, the coroutine execution is going to be suspended until we manually resume it. The way to resume it is with that continuation object. And whenever we get the callback from the barista, we call the resume. We can resume with a value here, fresh coffee in this case, or we could resume with an error if something happened. Another nice API that we could use on continuation is the invoke on cancellation. So if the caller cancels the execution of this coroutine, we can cancel the order by just doing this. So this is very nice, right? Because we avoid all the complexity of the nested callback functions and all that, and then in our coroutine code, we can call prepare coffee, and sequentially we are going to get the value right there to operate with it. Okay, now the meaty part of the talk. Repeat on lifecycle, how that's implemented. It's going to use suspend cancelable coroutine under the hood. FYI, this code is going to be surrounded by larger thingies that we'll see in a second. But in a nutshell, we're going to get suspend cancelable coroutine. And now we need to implement the restarting behavior that we just saw. So we are going to create our observer, the lifecycle event observer on that particular lifecycle that we are added as observer here at the bottom of the screen. Okay, so we mentioned that when the lifecycle is destroyed, we want to resume the execution of the coroutine. So let's get that implemented. If the event is on destroy, we resume it. That's it. Unit, we don't need to return any particular value with the repeat on lifecycle API. Now we need to keep track of when do we have to start the work and when do we need to cancel it. So for that, we're going to have the start work event and the cancel work event. If the event that we get from the event observer is the cancel work event, I'm going to cancel the ongoing coroutine, and that's going to be tracked in this long. So we're going to cancel it and we're going to set it to move. And now, if the event that we get is then I'm going to create a new coroutine. I'm going to assign it to launch the job. Okay, this add coroutine scope is coming from somewhere that we'll see in a second, but imagine that we simply create a new coroutine. And here, potentially, we just need to call block, and that would be right. But we are going to add some spices here just to make things a little bit more safe and secure. And the first thing, we are going to use a mutex. Because it is possible that if race conditions happen, like the life cycle state could be above and below that particular state very quickly, and we want to avoid race conditions. So we're going to guarantee that block is going to get created and cancelled, serially with this mutex. And we're going to use an internal before calling block because we want to wait. Scope is giving here some safety guarantees as well, but we are waiting for the block to finish. Okay, where is this coroutine scope coming from? That's going to be the first thing that we do when we call repeat on lifecycle. It's going to be there, the first line. Why? Because a good practice in coroutines, in this case, is to preserve the calling context. When someone calls repeat cycle, they want to make sure that block is executed in the same coroutine context where the previous coroutine's code was executed. And because we need to register an observer to the lifecycle, we need to do that on the main dispatcher. So we preserve the calling context using coroutine, and then we move the execution of the coroutine to the immediate dispatcher so that we can call suspend cancelable coroutine, which is going to add a new observer, and then we do the try so that finally, whether we get a cancellation or whether we resume executing the coroutine, we cancel the launch job, and then we remove the observer from the lifecycle. Okay, I think hopefully like everyone understood this. So a few nice things here, right? Like the coroutine scope to preserve the calling context, and then like mutex and coroutine scope to make sure that block finishes successfully. Cool, callback flow. Not much to say anything here. We know that this is a way to create a flow and emit items from any other like async solution that you might be using. For example, like it could be a callback-based data stream as well. It can handle back pressure. We'll see later how to do that. So again, with the callback API, now we are interested in listening to all the orders that the barista is preparing. So, and we want to get those orders as a flow instead of using this API. And for that, like we're going to get a function. We can define it, coffee orders. We are going to get a flow of coffee order type. We create a flow with using a callback flow. Callback flow is actually going to produce a called flow. So that, just to link that with what we learned earlier. And then on every coffee order that we get from the listen function from the barista, then we're going to call try send. That this is a non-suspend function, right? So this is going to be best effort. We are going to try to add it to the call to the flow that we created, and then we are going to use the await close API to wait for the collector to go away before we stop listening to the barista. In our calling code, we create this coroutine, and we can collect, and then every order that comes with a manual name, we're going to drink it. I love coffee, so why not all of them? And then how flow with lifecycle is using callback flow. It's like this is the first thing that we are calling. Callback flow, something that I didn't mention earlier, is that it creates a new coroutine. So right now we are in a coroutine context, and we can call repeat on lifecycle. So again, you see like we are using the repeat on lifecycle here as kind of the base functionality that we are going to keep reusing for other high-level APIs. Lifecycle, repeat on lifecycle, when we collect it, now we use the send API to do it. This is going to add back pressure, right? So if the collectors are not getting the item, we're going to wait for them. So in this particular case, we wouldn't be wasting resources, but this is safer to use. Because repeat on lifecycle is going to resume executing when the lifecycle is destroyed. When that happens, we just close the channel, and then we inform the collector that that's it, that there are no more items that are going to be sent. The other API is going to be that we're going to be using is produce state. This is what collect state with lifecycle API is using under the hood. And probably you're familiar with this with compose, that this is the way we can create compose states. And we are going to bridge asynchronous, potentially coroutines code, and we are going to be updating and hooking to the Compose's reactive state model. The nice thing about this API is that it's already going to handle the coroutines code for you, and cancellations and all that. So probably you know how this works. So produce state, every time that you give a new value to the value parameter, then it's going to update the compose state, and it's going to cause a recomposition in that particular composition scope. Cool. So collect a state with lifecycle. The implementation details is returning compose states, and then we are going to call produce state as soon as we start this function. We're going to pass all the parameters that we have to the produce state API, so that, like, should any of these parameters change, we are going to restart the block of code that produce state is going to do, the coding that it creates. Inside it, we call, again, very similar to the flow with lifecycle API. Lifecycle, repeat on lifecycle, we pass in the min active state. And with the collect function, like the to-do there is going to assign the value that we get from the flow, and we update the produce state value. I didn't mention it earlier, but we are passing a coding context as well, which is optional. And that's, we can use the with context to switch the context to whatever the developer might be interested in. And this is going to change where we are collecting and where we are going to be emitting those items from. Cool. So that's been like the implementation details of the 3 APIs. Main thing there to notice is that we are using repeat on lifecycle as the foundation of all the work, all the complexity there. And this is kind of a good segue to how to build good APIs. Coroutines APIs mostly. We need to make sure that we comply with the structured concurrency. We preserve the calling context as much as possible, but also we propagate exceptions and cancellation as expected. Otherwise, developers using your API are not going to have a great experience. Good design as well is foundation for higher level APIs. At some point, we'll reach the limit, right? But as much as possible, if we separate concerns properly, we can have enough granularity so that developers can hook into the right place and the right functionality that they need, and they could potentially build on top of it. Also, we need to have some sort of emphasis on explicitness and safety. We don't want to create like any race conditions inside it, any unexpected things to happen. The API should do what it's meant to do and nothing else. And then potentially educational value, right? If we are following good practices with APIs, anyone reading our source code should be learning like new things and should be happy with all of that. And everyone kind of makes mistakes. And so we also want to see, show one example of not so good design. And this is an API that actually landed in the first alpha version when the team released these APIs. And that's the add repeating job API. And we kind of added this API because it was a little bit annoying to have to create a new coroutine and call repeat on lifecycle every time that we wanted to collect from a flow in the UI. So we said, okay, add repeating job seems convenient, right? And this is the API definition. It's going to be quite easy. So just to save that one line of code, it's going to return a job, and it's going to do exactly that. Lifecycle scope.launch, and then repeat on lifecycle. Very easy, very convenient. But there are problems with these APIs, right? The first thing, as a spoiler alert, it's not respecting structured concurrency. So imagine that here we are in our activity, and there is some expensive init work that needs to happen. And then, like, naively, again, I can do, okay, I'm going to do some init work, and then I'm going to call add repeating job, and then I'm going to collect from this. And then anyone could think that if I cancel job, I'm going to cancel the repeating job, but that's not the case. Add repeating job, even if you cancel job, is going to keep collecting because it doesn't preserve the calling context. It's creating a new coroutine under the hood. And what's misleading here is that add repeating job is not a suspend function. And that's the catch, right? So we need to be very careful about how others perceive our APIs that we create. And we need to make, we need to be as safe as possible for things like this to not happen. So that's pretty much everything that I had for you today. More resources if you want to learn about this topic. You have a bunch of blog posts available to read. And kind of the main takeaways for this talk is that every architecture layer in your hierarchy should do the right thing. And not just the right thing, assuming that I'm making assumptions about how this other part of the hierarchy is doing or not. It's about, hey, I'm in control. I know what's my responsibility, and I know what I need to do. If I need to, if I'm doing, for example, expensive operations, and I need to switch to a different dispatcher, it is my responsibility to do so. I shouldn't expect other parts of the code base to make those assumptions for me. So every Arc layer should do the right thing. Collect using lifecycle-aware APIs. It's been like 40 minutes of bombing you with this information, but hopefully it's a no-brainer. You just need to import the right libraries. Create good APIs that comply with the structured concurrency. This is really important if you want the APIs to be used by your colleagues and people in the community. And a good thing to keep learning more and more is by reading the source code of what others are doing, reviewing PRs and all that. Thank you so much. I hope you learned something new today. I'm going to be around, so if you need any questions.
Android circle.
Okay, can we get rid of those chairs?
It's the Android Speaker. It's the Android Speaker.
Six, seven. Now I can hear myself on the camera, but I'm holding it properly like a singer, you know, very close to my mouth. If I hold it like a speaker far, it has a compressor. It's good. It has a compressor. I love it. I love it. Is that gonna be the same level from the lectern mic, roughly? Yeah, perfect. Perfect. Lovely. So happy. Thank you. Yeah, back. Okay. Thank you. Bye bye.
It's the Android Speaker. Troyes Baker. Troyes Baker. Estienne Troyes Baker. Estienne Troyes Baker.
It doesn't really matter if you start a process as a thread, as a coroutine of a global scope, or as an async class. In all those cases, you started a process that is asynchronous in relationship to your whole program. And that generates problems. You see, there are mechanisms to synchronize those processes, but it is easy when you have only two processes. But the more and more of them you have, the harder it is to manage them. And then we can see real problems with concurrency. In a way, it is similar to this classical go-to statement that you hopefully do not need to remember about, that was extremely powerful,
but at the same time highly uncontrolled, and got replaced in modern programming with control structures. We'll get back to that later in this presentation. The same process is now happening with concurrency. And the solution to the concurrency problem is structured concurrency. My name is Marcin Moskała. I'm a consultant, trainer, and contractor, JetBrains partner for teaching Kotlin, GDE, and Android, author of 6 books about Kotlin, including Kotlin Coroutines Deep Dive and a big learning experience, Coroutines Mastery. I don't think I need to tell you about it. If you haven't heard about it, I guess you will hear about it soon. So the essence of structured concurrency is, of course, building relationships between our processes. In Kotlin, in Kotlin X coroutines, this is how those relationships typically look like. We start coroutines on a scope, we launch them, and then if we need to start asynchronous sub-processes, we start them on a coroutine scope. But of course, structured concurrency nowadays is not only in Kotlin X coroutines. Kotlin X coroutines was one of the pioneers in this area, one of the early adapters of structured concurrency. But this paradigm is now present in many languages, including Python, Scala, Java, or Swift. The tree, the structure looks very similar in all those technologies. This is how it would look like in Java. We would start threads on executor, and we would also create a scope to start sub-processes. But let's concentrate on Kotlin X coroutines in this presentation. I just want you to know that nearly everything I'm telling you here is applicable to those other technologies, because it's a modern consensus for how structured concurrency should work nowadays. So let's start with 2 main concepts. How do we start coroutines? In Kotlin X coroutines, we launch coroutines on a scope, which associates those coroutines to this scope, makes these coroutines children of this scope. On Android, we use our scopes like ViewModel scope, Lifecycle scope, and Remember coroutine scope, which are associated to a specific view or component. You can also launch coroutines in other ways. In case of flows, you use launch-in or state-in or sharing, but all of them launch a coroutine on a scope, typically using launch under the hood. Now, starting sub-process. If you are already running on a coroutine, you shouldn't start new coroutines on a scope. You should first create a new scope, with a coroutine scope. Such a scope is a children of a caller coroutine. So whoever called this function will be a parent of this coroutine scope, and from which you can start asynchronous coroutines. What you shouldn't do is that you shouldn't start coroutines on a scope, because that would make those coroutines children of this scope, so it would break structured concurrency. They wouldn't have any relationship to the caller of this scope. So this is an incorrect pattern. How does it work in Kotlin? Everything is based on 2 mechanisms. First, the implicitly passed scope. So the asynchronous coroutines are started on a scope. They also provide a scope for inside their lambdas, so that coroutines started inside those coroutines are children of those coroutines. But what about coroutine scope? Coroutine scope provides a scope for asynchronous coroutines, but it also builds relationship to the caller. How can it do that? Every suspending function implicitly passes a continuation. Continuation can access a coroutine context. Coroutine context includes a job. This way, coroutine scope can build this relationship. There are a few ways how this structured concurrency can be broken. One way is to launch something on a scope. This is sometimes acceptable if you know the consequence of this process. This is a way to start the background processes, but it breaks structured concurrency because it associates this coroutine to the scope, not to the caller of this function. Other approaches are considered absolutely unacceptable. Launching coroutines with a job, or using with context with a job, or supervisor job, all of those are considered an anti-patterns in modern programming. You should also know that in flows, the relationship are also built in exactly the same way. Flows respect structured concurrency. So if you define some complex flow, flow inherently by default operates on a single coroutine, but there are some processing functions that start new coroutines, like buffer, that start a new coroutine for everything above, or flat map merge that start a new coroutine also for everything above, but also for sub-processes. So here we would have a hierarchy of coroutine that is associated to the caller of this flow. So the caller would execute map function, but then there is an asynchronous coroutine started by buffer and asynchronous coroutine started by flat map merge. They also synchronize with each other by using channel inside. All right, now you know how structured concurrency is built, how to maintain it, but why do we have it? What problems it solves? And when I asked Android developers about it, most developers only think about cancellation, which is one of the reasons why we use structured concurrency, but only 1 out of 5 key problems that structured concurrency solves. So let's talk about them one after another. Cancellation is the simplest one, most obvious one for Android developers, since we treated cancellation very seriously since early days of Android development. And structured concurrency gives us effortless, simple cancellation. If you cancel a scope, you cancel its children, you cancel its children, and everything gets cancelled. Let's see it in practice. If you launch a coroutine on a scope, if you cancel this scope, this coroutine gets cancelled, coroutine scope gets cancelled, async functions get cancelled, and requests also get cancelled. Is it important? How much we can save on that? And here I prepared a very clear example of how much we can save from this basic cancellation mechanism. Imagine that you, this also works in backend. If you make a request using a suspend function, define a request using suspend function, if you lose HTTP connection, this function gets cancelled, its children gets cancelled, async gets cancelled, everything gets cancelled. Okay, how much can we save thanks to this mechanism? So imagine that you implement a service like a Skyscanner that I used to find flight to get here on this DroidCon. Now, on a Skyscanner, you are searching for the best flights, but to get the best flights, you need to make requests to all the different providers to know what flights we have available. Now, this is very expensive because that very likely starts many requests to many services. Actually, every such search costs cents or close to $1 in extreme cases. Now, imagine that a user started a search, but immediately left it because maybe he decided he needs a different date or he needs a different airport, so immediately left the screen. So without structured concurrency, in most typical front-end application, even though user would change the screen, the previous request would still remain active and all the requests going on in the background would still keep being made. Now, with structured concurrency, of course, a process of fetching connections is associated to the scope of a view. So once view is disappears, we should have this process cancelled, and in result, this connection should be cancelled. And if structured concurrency is also used on backend, the cancellation of a request or of a WebSocket should automatically result in cancellation of all its children, so fetching all connections, and immediate cleanup of all the requests. So that can save us a lot of money, and it does save us a lot of money. We knew that since the beginning of Android. We treat cancellation very seriously, and structured concurrency haven't gave it to us, it just made it much more simpler for us. But that's not the end of the structured concurrency advantages. Here is something that we haven't got before structured concurrency. That was actually one of the big selling point of structured concurrency, exception handling. I guess it was one of the biggest selling point in Java to introduce it over there. So let's get back to this simple example where in a process we start asynchronous sub-processes like fetching flights and hotels at the same time, so that so that user can wait less time to receive this response. Now, what should happen if one of those requests throws an exception? If, for instance, search hotels fails. Now, what do we expect to happen? We generally would expect this search to throw this exception, but we would also expect, and we would expect it as soon as possible because why waiting? And we would also expect search flights, the other request, to get cancelled. And this is what happens thanks to structured concurrency. Exception is propagated to coroutine, to async, propagated to the parent coroutine scope, cancels children, so async, so it cancels search flights, and exception is thrown. Now, it might look obvious, but it isn't. And making this work this way was actually quite hard, and it required this coroutine scope. That's the main reason why this coroutine scope is in every technology implementing structured concurrency. It has different names. In Java it is also called a scope, but in Python it's called nursery. But it must be there, and it is there in all libraries that support structured concurrency. Why? Consider alternative approaches. Let's start with the most obvious ones, one where coroutines are started on a scope instead of on the color of a coroutine. We already know it's incorrect because it breaks our tree structure, but how would it behave in terms of exception handling? So if we had an exception in search hotels, this exception would be propagated to the scope. What would this scope do? Well, we don't really know. It might fail and cancel everything inside of it, but more likely this scope is using supervisor job inside. And at least in theory, because in practice in Android it would break our application at the moment, but in theory, if we haven't got, if we overwritten a coroutine exception handler, this scope would ignore this exception. So if this scope would ignore this exception, what would happen to our search function? Would it throw this exception? Well, finally it would, but it would first await for the completion of search flight. So the process of searching flight wouldn't get cancelled. We would need its completion because its await is first. And only then we would throw our exception. So I hope you can see it's clearly not the right behavior. Okay? So let's now consider another approach that used to be pretty popular at early days of Kotlin X coroutines, starting those sub-processes directly on the caller scope. So no super coroutine scope inside our function. We just pass coroutine scope either implicitly as a receiver or explicitly as an argument. Doesn't really matter. We pass our caller scope. What's wrong with that? Let's analyze the same situation. Search hotels throws an exception. So this exception propagates to async, and async propagates it to its parent, so directly to the parent scope. Now, how would this scope react to that? Again, we don't really know. If this were a supervisor scope, it would ignore it unless we are on Android and coroutine exception handler breaks our application. But let's say, most likely it wouldn't ignore it. Most likely this scope, this coroutine would break, would cancel. Okay, it would cancel other children, but it would also cancel everything else. So we wouldn't be able to safely catch this exception and handle it. So one of the most basic presupposition about functions, when you call a function, you expect that if this function fails, it throws an exception. You don't expect it to break your coroutine. Yeah? So one of the most basic presupposition of functions would be broken. And that's why this approach is incorrect. And also search flights await would call coroutine exception handler, not the exception from search hotels, but that makes very little difference. This is clearly an incorrect approach. Okay, so what other advantages do we have from structured concurrency? Because we covered only 2 of them so far. Another one is configuration, something that is used also quite widely in Android. So thanks to structured concurrency, the configuration of our coroutines can be only specified in the scope, and it is automatically propagated to all its children. And as you know, you can change this configuration. We especially often change our dispatchers, and if you specify a dispatcher from a coroutine, it is set not only for this coroutine, but also for its children, which makes configuration management, dispatchers management much easier and much more intuitive, which is a great advantage on Android. Another one is observability. Here I used a screenshot from a plugin that is drawing a nice hierarchy of coroutines. In a typical debugging session, we have this list that we can extend, but it doesn't change the key idea. The key idea is that thanks to the fact that our coroutines are structured, we can more easily analyze them and analyze what's going on in our application. Thanks to that. Like a simple example, imagine a backend, a bit extreme. Imagine a backend application that handles 100 requests, every single one in a different coroutine, and every single one of those requests, let's say, have on average 10 asynchronous sub-processes. Now, without structured concurrency, you would have 1,000 coroutines, and you wouldn't know what is the relationship between them, which one of them are handlers, which of them are some sub-processes. There would be a complete mess. Okay, internally they would wait for each other, but analyzing that would be extremely hard. Now, with structured concurrency, you have a nice coroutine per request, and pretty often you can associate those coroutines to requests thanks to the specific context we associate. And then for each of them, you could analyze what sub-processes are currently active, which gives us much nicer observability. And finally, the last one, I left it to the end. It is the hardest one to explain, but it was the main reason, the main argument in the original papers supporting and promoting structured concurrency. So some will argue it's the most important argument behind introducing this technology, this approach. The clarity of our application. So before we understand it, I want to get back to this go-to metaphor. So before we had in the ancient times of programming, one of the most basic basic block to control our application was a go-to statement. Go-to statement was a statement that allows execution to jump at a specific line of code. Now, go-to was extremely powerful. It could be used to replace all the control structures that we have, for loops, if statements, functions, whatever you wanted. But it was too powerful. First of all, it made our code extremely hard to analyze. But it also made many other blocks impossible. So for instance, if we had go-to statement in our program, it would make no sense to have a try finally block. Why? Because this try finally couldn't guarantee that finally is called if you can jump out of it, out of the try block. You cannot guarantee that a resource is opened if you can jump inside this block. Many things make no sense if we allow go-to statement, because it is uncontrolled. It has no clear entry and exit point. And the solution to the problem with go-to statement was functions and control structures. And the key characteristics of those was that they all have a clear entry and exit point. It doesn't matter what happens inside. You can loop inside, jump inside, whatever you want, you can do it. But for every function and every control structure, you have a clear entry and exit point. And thanks to that, you can analyze this block in separation from anything else in your code. You know nothing will jump inside of it. You know nothing, you cannot jump outside of it. You have clear entry and exit block. And if you go in here, you must go out of here. That's like with kids on a kindergarten. It's much better to have the, attractions where you know that if kid goes in from one hole, it goes out of another one. If there are multiple, have fun. See? Now, the same problem we have with concurrency. As I told you, if you start a process that is asynchronous in relationship to our program, it is very hard to control it because you finished your function, your block, but you don't know if what was started by this process isn't still going on and isn't still making some changes that we might not be aware of. And this is, and the solution to this problem is structured concurrency. This is exactly why functions like coroutine scope functions, coroutine scope, supervisor scope with context with timeout, this is exactly why they must await their children completion. Why they cannot allow these children to outlive the scope itself. Because only then we can think about suspending functions or about coroutine scope as a block of code in separation of what's going on outside of it. It's like with this control structure. It gives us clear entry and exit point, and you don't need to think outside of it. I know it might look very unclear at this moment, but I will show you two examples. Exhibit 1, awaiting processes. Let's say that I create a unit test that starts some asynchronous process inside of it. And inside of this asynchronous process, I have some assertions. So this assertion should clearly fail, but of course this test wouldn't fail for two reasons. One reason is that an exception inside this thread wouldn't be propagated to the thread, to the function itself. And the second reason is that this test wouldn't await this thread completion. So this test would complete immediately, and this assert equals would be called after this test is completed. So both of those problems are solved by structured concurrency. When you use run test, it must await its children completion. It can sometimes be annoying when we have coroutines that work forever and we need to close them or cancel them. But it guarantees to us that by default, if you start some sub-processes, this sub-process won't be ignored, won't be forgotten. That run test will await the completion of this launch. Launch will wait 1 second, make this assertion, and fail, which is an expected behavior. Okay? This is given to us by structured concurrency. The same with the main function or many other things. If in main function you start a bunch of coroutines, suspend main, to start a bunch of coroutines, you must use coroutine scope, and then coroutine scope awaits the completion of those coroutines. That is given to us by structured concurrency. Exhibit B, closing resources. I mentioned that already. Try finally. I will, for the simplification, use this useLine functions on a file. I hope you know it. It's a function that opens a connection to a file, gives you a sequence that allows you to read lines from this file, and then closes a connection to this file. Yeah. Now, this is a very popular block. We have many such blocks that are closing resources in finally. And that, of course, is based on the assumption that the lines and the processes started inside of it cannot outlive their execution. So if we finish the Lambda, everything that it did, it was doing, is finished as well. And of course, this pre-assumption is respected if you extract a function out of it, or if you use any control structure inside of it. All of them will perfectly respect it, so this is fine. But this pre-assumption wouldn't be respected if you start an unstructured concurrent process. So, for instance, if you used a thread, now you won't see any lines because thread starts a process, but consume lines immediately ends, closes resource, you cannot read this file. Okay, can you see the problem? So structured concurrency isn't allowing that. If this were a suspending function, to launch a coroutine, to start the coroutine, you would need to wrap it with a coroutine scope. Coroutine scope would await the completion of this coroutine, which of course would make this launch a nonsense if it does nothing, because it starts an asynchronous process, but the coroutine scope synchronizes it. In this case, it makes nothing. We can replace it with a regular function. But in general, as you can see, structured concurrency gives us the same guarantees that we generally expect from functions, that their sub-processes cannot outlive the process itself, they cannot outlive the function itself. So if function is completed, what it was doing, what its all sub-processes are completed as well. Okay? And this is the key idea of structured concurrency. So to remind you, there are 4 problems that structured concurrency solves: cancellation, exception handling, configuration, observability, and clarity. I hope that after this presentation you will have a deeper understanding of this concept. I also go much deeper into structured concurrency and other coroutine-related concepts on my course, Coroutines Mastery, a 5 weeks course. It starts next week, so another occasion will be next November, next year. And we already have 150 people. We'll have a great 5 weeks. I think we'll have a lot of fun. So yeah, it is something I'm very excited about. This was everything. I would like to welcome you for questions, and for now, thank you for your attention. I can see there are microphones here and there. If you have any questions, ask me anything. It doesn't need to be related to structured concurrency. It can be related to absolutely anything else, including my work, my courses, I don't know. Yep, go ahead. Oh, I will repeat this question, don't worry. Mm-hmm. No, yes, in a sense. Yeah, so the question is about dispatcher, or in general about context propagation in flows. So when we start coroutines inside flows, what is their context? So the rules are very similar as as with suspending functions. So let me just find it. Okay, here it is. If you don't change the context, because there is of course a flow on function to change the context is inherited from the caller coroutine, just like with a coroutine scope. So functions like buffer or conflate, they both start an asynchronous coroutine for what is above, and they send to the coroutine from below, and they communicate via channel inside. So this coroutine sends to this channel, those functions receive from this channel, and of course, depending on the size of your buffer or the conflation option and the behavior of this, the configuration of this channel is different. Yeah. But yeah, by default, this coroutine is started on the scope of this coroutine, just like with coroutine scope. And the same with flat map merge, it also is started on the scope of this coroutine. So by default, the context goes from down to the up, unless you change it with flow on changes it for everything above it. Simple heuristic. Anything else? Oh, sorry, there is a hand over there. You have a microphone quite close to you, so it might be nicer to others in here. Can you turn it on? That doesn't work. Okay. Can you get slides? Yes, I will publish them on my Twitter. It's at Marcin Moskala, just like my name and surname. All right. If you have any other questions, please find me around. I will also find a way to give away books. Maybe I will make a contest again with my coroutine games. Maybe this time we'll use my flow processing game, a new one. But yeah, it will probably happen soon. For now, thank you again and have a happy conference. Yeah.
Ale nie tylko, bo również nie dawałyby innych benefitów, czyli nie budowałyby odpowiedniej hierarchii.
No tak, hierarchia.
I co jeszcze? No i nie dawałyby tego clarity, nie?
No
o którym mówiłem.
Nie wiem skąd on idzie, tak? Tak, tutaj mamy scope, który jest coroutine scope, a nie ten global scope, tak? Dobra. Chyba kumam. No dobra, muszę jeszcze to zrobić. Dzięki.
Jakby coś, zaczekaj sekundkę.
Troy's Baker. Let's the influence maker. Influence maker. Androids Baker.
Can I? Should I?
It's the Androids Baker. It's the Androids Baker. Troy's Baker. It's the Troy's Baker.
Silence. We can start. Brown. Okay, hi everyone. Welcome to Shaders Are Awesome. I am Sebastiano. I am a UX engineer at Google. And today we're going to be talking about shaders. Now, some of you might be wondering, what are shaders? In a nutshell, they are just some code that runs on the GPU to decide the color of pixels that show on screen. There are many kinds of shaders. Today, we're mostly interested in fragment shaders. Fragment shaders are the only ones you can use in Android anyway, but there are many other ones if you're doing like 3D graphics that you can have fun with, but we don't care. Now, shaders are very, very powerful, and they allow you to do things that wouldn't normally be very difficult to do with normal Canvas APIs. You can go full Lysergic if you want, or you can even try and emulate a video game aesthetic in your UI for whatever reason if you want to. Like, people are doing crazy stuff with fragment shaders. They're super powerful. But more realistically, you're going to be doing something like using Chris Payne's Haze library that uses shaders under the hood to have fancy blur effects. Or you can ruin your old UI if you want. I mean, the library is great. You can also have fancy UI, like you have a weather app and you are in London. I mean, I prepared this in advance. I'm sorry, today's actually not showering, but That was the expectation. How do shaders start? Well, the foundational API for graphics that Android was built on is OpenGL, and OpenGL defines its shading language, which is called GLSL. Not very inventive there, but when you create shaders for your Android app, they're not going to be GLSL, they're going to be a dialect of GLSL, and specifically either SKSL, which is the Skia shading language, or AGSL, more likely if you're doing Japa Compose. If you're doing Compose multi-platform, SKSL is what you will be using instead, but they're very similar. Now, GLSL is a C-like language. It is optimized for running on the shader units on your GPU, which are some specialized piece of hardware that make running shaders a lot faster than it would be to run your Kotlin code for graphics. Main thing compared to C is that they do not have pointers, and you cannot do recursion. If you try to do recursion, the shader compiler will yell at you, which is unpleasant. But at the core, a shader is a function that takes an input and outputs a pixel color. There is a main function, like any good C-like language, and that function is called for each pixel that the shader is applied to. Now, let's look at a simple shader. That's a simple shader. It's kind of boring, but there's also already something that we should look at. So first thing is we get a parameter passed in, that's always passed in AGSL, and that is the coordinates of the current pixel in pixels. The origin in AGSL is at the top left, same as for normal Android canvas draw. That is a different from other dialects of GLSL, like SKSL, where the origin is actually at the bottom left. And we also return something. What is that something? Okay, let's break for a second. You see there's half4, there's float2. Well, those are vectors, essentially arrays, one-dimension arrays. And the first part, the letters tell you the type. So in this case, half precision or full precision floats. And the second part tells you, well, how long they are. In Kotlin, well, there isn't really a close match in Kotlin for half precision float. There are 16-bit floats. Android does define a half type that you can use, but it's not very portable. So if you're thinking about writing code that is portable to other platforms, probably just want to use floats instead. And then floats are floats, same as. Okay, let's look at for a second that half4 that we are returning. Now, if you've been paying attention so far, I hope you did, because otherwise you have a very short attention span. The thing that the shader does is it returns the color of the pixel. So, unsurprisingly, that vector is actually a vector with RGBA coordinates. Notice that, contrary to Compose, the alpha is the last component, not the first. Now, if you change that number from 0 to 1, now the output is not transparent anymore, but it's instead full white. No surprises here. What you're actually writing is some syntactic sugar. It's actually that, so you're effectively creating a vector where all the components have that same value. And we can prove it if we change the blue and green to 0, then the output is red, fully opaque red. Okay, that is easy. Let's step it up a bit. This nice gradient has some new concepts applied to it. First of all, we have a uniform. A uniform is essentially a parameter. The parameter is passed for the same invocations for the same render pass to all pixels. You cannot pass different parameters to every pixel. All the pixels get the same parameters, and you have to figure out how to use those parameters in a useful way. In this case, we're just passing the resolution of, or the size in pixels of the bounds that we're drawing in. How is that set up? Well, first thing is you create a runtime shader from your shader code, and then you create a brush to draw with. And then the next thing you do is when you're drawing with that brush, you can set the uniform. In this case, it's a float uniform, where we're passing the name of the uniform and then the values that go into that vector. Okay, so we have that done. We understand how the resolution uniform works. The next important thing to notice is that we are doing UV calculation. Now, UV essentially stands for normalized coordinates. What you're doing is making sure that whatever the bound's actual sizes are, you're always counting them on a range from 0 to 1. So the origin is still 0, 0, and the opposite side to the origin is 1, 1. That is useful because it saves you from doing a bunch of math later on. Always good. Let's step it up again. Let's make it animated. So to animate a shader, you need another uniform, which is the current time. And in this case, I'm just using uniform to apply a sinus wave to the blue component. And so you get that animation there, where the color slightly changes over time. How do you set this up? Well, we look at the setup we had before with the box and the modifiers, and we change it a bit. We create a new component, which is the animated canvas. We'll see it in a second. We set up the time float uniform, like we did before for the resolution, and just draw again. Now, the animated canvas is not a particularly interesting composable. The interesting part is actually the way the time value is produced. So we use the produce state API that comes from Compose, and then it provides us with a suspend lambda. And we do an infinite loop in there where we wait for the next frame. We get the wall time that is current at the time that the frame is being drawn, and then we pass that to the state that is then set on the uniform in the shader. It's a bit of a round trip, but that's what it is. It's important to notice that because we're using time with floats, there is a loss of precision the further away you get from 0. So it's important to remember that if your shader is going to be running for a long time, you want to make sure that you reset to 0 every, say, 24 hours. You should be fine up to 2 or 3 days, but really, why do you need it to run for that long? Let's draw a circle. Sounds easy, right? Let's start from our basic shader code. Now that you will know by now, the output's white. How do we decide, given the parameter we have, which is the coordinate of the current pixel, whether the current pixel should be white, so inside the circle, or black outside the circle? Well, I'm sorry to answer maths. It's a circle, so it's not that hard. It's just we need to know what's the center of the circle and what's the radius of the circle. And once we know that, well, everything that is inside that radius from distance from the center is the circle, so it's going to have to be white. Okay, let's put in some code. Now, that's the output we currently get. Is that what we expect? Yes, that's correct, but let's go over the code and see why. So the first thing we do is we, again, compute the UV, and then we define the center coordinates in UV. This is why it's useful to have UV coordinates, because then you know that the center is at the center is just 0.5. You don't need to bother how big the canvas actually is. Then you might actually notice earlier, I'm doing some weird stuff when I'm doing .xy. That is called swizzling. It's essentially a syntactic sugar that shading languages have, where you can create a vector from another vector by using names for the components. So there are 3 sets of letters that you can use. So X, Y, Z, W, or RGBA, or STUV. You can choose any 3 of them, but you cannot mix and match. And that's useful if you want to create a new vector that is longer or shorter than the one you have, or you want to change the order of parameters, so just use the letters to say second, first, second, third. So you would be like X, Y, Z, for example. Anyway, that's step number 1. Step number 2 is, well, we talked about distance, so let's compute the distance. By the way, distance is a built-in function, so you don't have to define distance by yourself. And what we're doing here is we are computing the distance between the current pixel UV coordinates and the center, and then we're offsetting them so that it is 0 at the edge where we want it to be. And then we are saying, okay, the color we are setting is a vec3. Vec3, by the way, is the same thing as float3. There are aliases for stuff. The types are fairly simple anyway. And we're setting all the 3 coordinates of that vector to the distance. So it's going to be a gray if you interpret it as a color. And that's indeed what we're doing. Now, to make it look like an actual circle we wanted to draw, we can use the step function, which is a step function in a mathematical sense. So anything that is below the threshold, which is 0 in this case, is going to be black, and everything that is above that is going to be white. That is fairly trivial usage here, but it can be useful if you're doing multiplication and scaling and stuff like that. We have been using a very simple SDF that stands for sign distance field. They're essentially mathematical functions to define shapes that work in shaders. There are very complex ones. This is a lightning talk, so I'm sticking to a circle. But the interesting thing about SDFs, which also, by the way, some people call sign distance functions, don't care, it's the same thing. You can see either one. They're useful because you can define complex shapes by adding and subtracting them. So for example, I can carve a hole by defining a second circle, which has the center at 0.625 and has a radius of 1/4. And then I can subtract that from the original circle, and I have this googly eye kind of thing. And then I want to make it creepier, I can add another circle inside of that circle. So you get the idea. That's a basic concept. And you're going to be building a lot of shader functions using SDFs. I don't want to take the whole day, so this is most of what I wanted to say. This is just an introduction to shaders. There is a lot of material out there. This is a shader, by the way, in case you hadn't noticed. You can have your UI looking like that if you want. I wanted to thank you for being here. I'll be around if you have questions. I might or might not be able to answer them, but I have put together a list of links in my blog. There's the link, or I'm going to be posting it on social as soon as I have time. And I have a bunch of resources there. There's pointers to Shader Toy, which is a huge collection of shaders that you can use. There are shader playgrounds where you can test stuff. There's a lot of stuff that you can use there. And with that, I am done. Thank you very much, and enjoy losing your sanity with shaders. Any questions? Yes. There's a microphone, 1 sec. Okay. Is it intentional? It might not be live yet. It's timed. I might have mistimed it. I'll double check. Time zones are hard, okay? I was in a different time zone. Yeah, it's a 404. I'll fix it, don't worry. It's fine. Second question. Microphone.
I have several questions. The first one would be about Compose. I've been recently playing with shaders, maybe you're familiar with. So I noticed a thing that in Compose we have to create runtime effect,
Yes.
basically on every frame. Is it something, well, when in computer graphics rendering, you usually try not to create objects inside render loop. Is it something maybe you are aware of, or something being looked into, or something like that?
I don't know. Okay. That's the short answer. The long answer is, I know that the shader compiler generally does some caching inside, so it's not, if you're passing the same code multiple times, you shouldn't be recompiling it. So that saves you at least that part. But I don't know.
That's a Compose particular thing because it's on side of Kotlin.
I know it's an object allocation, but that's why you're supposed to be using uniforms in that case if you need to parameterize instead of recreating.
Okay. The second question is, are you aware of something like being able to extract the shader code? Because sometimes I would like to see what exactly was compiled, because there are GPU specifics like about branching.
Debugging is painful. Debugging is setting colors of pixels and figuring out why it's that purple instead of green?
Yeah, exactly. That's kind of more tooling question, but like you don't know. Okay, so then it's kind of feature request.
As far as I'm aware, once it's compiled to, I think it's SpearV probably, there's a shader intermediate language that is then used for rendering. That is, it's gone. You don't see anything anymore.
Okay.
There's no logging either, unfortunately, because it runs on the GPU.
Yeah,
so there's
exactly.
no channel back from it.
Yeah. Okay, I see. Thank you.
What you could do is you could render debug information. So you could figure out like a mental model of, red pixels are giving me the wrong result that I don't expect here. And so instead of drawing the actual result, you could draw a debug color instead.
Thank you.
Do the shaders work on Compose previews?
Probably not. But I haven't tried. I haven't dared.
Okay, feature request to Google. Please make shaders work in Compose previews.
Okay, file a bug, please.
Okay.
Any other questions? Feature requests? I'm taking feature requests on Buganizer. Okay, thank you very much. Have a great conference.
It's the Androids Baker. It's the Androids Baker. It's the Androids Baker. It's the Androids Baker. Androids Baker. Androids Baker.
All right. Oh, here we are. We're live. Hi, DroidCon London. How are you this morning? I know we're right before lunch. My name is Winchua Dow. I am slightly hungry, but more excited to see you. And if this is giving you a little bit of deja vu, yes, I spoke here last year about custom layouts, and I'm back again. I promise I will talk about predominantly different things today, specifically something called subcomposition. But again, oh, by the way, this cute, lovely pink QR code, actually, 2 questions before I start, or rather a statement and a question. QR codes will be the code for this talk, which I think are updated. And is this visible? Like, folks in the back, can you read this okay? Thumbs up. Like jump up and be really angry if you can't read it. We're good? Okay, dark theme is everyone's preference today? Cool, all right. Awesome. Did I hear a woo for dark theme? So this is going to be a little bit of review from last year, but I really like to start with a common base when we talk about something like the inner guts, rather, of composition. So we in Android love a life cycle, and in Compose, it's no different. We have a process by which those lovely @composable annotated functions that we've been using for the past several years to create our UIs, there's a process to get from code to pixels. And that process, that life cycle, has 3 phases. And the first one is called composition. Not confusing at all, but what happens in composition is that is where you tell Compose literally what's on your screen. There's some buttons, there's a text edit, there's all these different things, right? So when we create these @composable annotated functions, we are telling Compose what's on the screen, and then during composition, each one of those functions is invoked, is called. Now, the result of those invocations are what are called emissions, or you can say that these composables emit something. That something is a node in a tree, and that tree represents your UI hierarchy, not views. That was the old world. This is the new world. And so each of those nodes that are emitted build out this tree, this in-memory representation of your UI. So now we know what's in the UI. We need to then figure out how big it is and where it goes. And that is done through the layout phase. So if you were a custom view person like myself, this might sound familiar, but what we need to do during this layout phase is to measure each of the elements in the UI, determine how big it is, and to place them, give them some XY on the screen. And so for each node that we have now emitted from our composition, each of those nodes gets measured and then placed. And in a phase called drawing, which we will not think about or touch at all, pixels are finally drawn on the screen. So what I think is super fascinating about Compose phases is that, or rather composition in general, is that, I spend many hours of my life trying to convince people that digging into composition, digging into custom layouts is not a scary thing. In fact, it's a very useful thing. And it does feel a lot, though, like a departure from your everyday Compose life where you're building out your functions, right? And part of our everyday Compose life now is something I like to refer to as state hygiene. State literally, and I guess in a philosophical way, really drives UI development in Compose, yeah? And so one of the things that we learn is that Compose was built to be able to be driven by state. So when state changes, things get recomposed, redrawn. When things don't change, when state doesn't change, Compose is very able to smartly skip recomposition on a whole or part of our UI. And that's not just kind of a very holistic occurrence. This can actually happen in each of these phases per phase. So that is what is called phase state reads. And basically each phase, composition, layout, at least as far as we are concerned, has some state that it reads. And just like kind of the general idea that, okay, when my state doesn't change, whatever part of my UI that reads that state doesn't have to recompose, the same happens at a phase level. So if I have some state that is read in my layout that isn't read in my composition, and whatever state is that is read by my composition doesn't change, then composition can be skipped and just layout is run. So this ability to kind of optimize and also very specifically and very smartly place our state reads in a certain place to get certain benefits, this process skipping happens at each of these phases, which is going to be important. So when you're working with custom layouts, there's a lot of different ways to do it. There are actually modifiers that allow you to piecemeal control the measurement and layout, or sorry, the measurement and placement rather, ViewBrain, measurement and placement of individual elements. But for this talk, and a lot of times when I mean, this is like my personal preference, I like using these foundational composables that are found inside of Compose. So a lot of times, most of the time if you're using custom layout, you're going to use the first one, which is the layout composable. And very occasionally, maybe 3% of the time, or in this talk, you're going to use sub-compose layout. And again, what I think is so interesting, just like in the old Vue days when we had their callbacks that kind of piped us into the Vue lifecycle system on measure, on layout, and on draw, you have places inside of this layout composable where you can see the phases happening. So composition, again, is where we tell Compose literally what's on the screen, just the raw elements that are in the screen. And where do we do that as Compose developers other than the content block? And that is that composable, that declaration of all your different composables. And that's where we tell Compose what's in there. And that's where that composition actually happens. That first phase happens within that content block, right? Each composable function is invoked and emits a new node. So all those nodes that those functions emit become measurable. So layout has 3 parameters. It has modifier, of course, a content where composition happens, and something called a measure policy. Measure policy is where layout happens, and you can see here that the measurement is taking place inside of this Lambda, this measure policy. And when I get my nodes, composed by my composition, emitted by my composition, they're actually passed to the measure policy as parameters. But they're called measurables. They have been composed, and now they can be measured, so they are measurable. And along with measurables, we get a second parameter into this measure policy called constraints. It's basically the min, max, width, height that this composable is allowed to be. And so in this area, we take our measurables, we call a measure function on them, passing in the constraints, and we get back placeables. Placeables are nodes that have been composed, measured, and now can be placed. And we do the placement by calling within our measure policy, the last thing you have to do, the compiler yells at you if you don't, is to call this layout function. It takes 3 parameters. The first 2 are the actual final width and height of your composable. And the last one is a lambda where you do the placement. So that's where you generate your x and y and usually place relative is the best one to do, but you place each of those elements at those x and y. So I gave this example last year about, and a lot of times when I'm trying to sell folks on custom layouts, because we all care about performance, so I generally come at it from a performance tack, because I think it's like the most dramatic and the most easily understandable that we want to get rid of jank and make our UIs beautiful and perform well. So the example that I went through last year, and something that I've actually done in my real life, is create timelines. And there's different ways of doing it. I actually did do 2 implementations in my real life. Actually more than that, but basically I started off with a row, just like the out-of-the-box compose row, and then eventually I ended up at a custom layout implementation. So what's happening in this schedule track here is that I have 2 versions. I have one created out of the out-of-box row, and I have one using all that stuff I just talked about in a custom layout. Now, where this comes in is kind of how this behaves. So these are classes at my local fitness club. As you can see, they have a start and end time. They're varying durations, so that's varying widths. I can scroll them, and because I'm an engineer and I don't know how to name things in a not engineering way, I have a zoom level, which I call DPs per minute, and as I move this slider, the number of DPs that represent each minute changes, so that's how I do zooming in or zooming out of my schedule. Now, I'm going to open up Layout Inspector, and if I look at, you can see Layout Inspector here, my 2 versions. If I drill down, I know it's a little bit harder to read, but in Layout Inspector, there's this panel here that is next to this panel that allows you to drill down into your composable. And if I look at my schedule row rack, so again, that's my out-of-the-box implementation, and my custom layout one, which is the bottom, and I can see inside of each of these the individual session blocks, yeah? So if I'm trying to figure out how performant my layout is, I can look at these 3 columns. The first one is going to be the number of times the composable on the left has recomposed, and there's a third one, the middle one, don't worry about that. The third column is the number of times recomposition has been skipped. So if I move this slider, you can easily start to see the numbers start to accumulate every single little bit that I move the slider. So in my row implementation, you can see here that this left column with the bright white numbers is the not nice column where we are recomposing. And as you can see, every single time I'm moving the slider, the numbers are just going up and up and up. If I look at my custom layout, oh, how nice is that? That third column with the slightly gray numbers, those are recompositions that have been skipped. And so you can see just the dramatic difference. Now, I do want to kind of affirm the notion that you should never pre-optimize, and that even with Compose, an extra composition here or there is not anything to worry about. I've heard folks on the Android team say, oh, they wonder why people are so worried about every little composition. But certainly in a situation like this where I have possibly many, many elements, I'm scrolling, I have all these things going on, 300 compositions versus no compositions is kind of a significant difference, yeah? So you can kind of see here where the benefit can be. And just to kind of go over why is this happening, so I mentioned that composition shows, tells Compose what's in the screen. And it isn't until layout that we want to tell how big and where things eventually go. Now, for the implementation of this, I had to do a lot of math, and especially for row, because the way that row works, and here's this implementation for that row version, the way that row works is that it lays things out consecutively. So in order for me to have those gaps between classes, I had to make spacers. I had to do a bunch of math, and I had to make spacers that were a certain width and do all that. So this is actually layout logic, right? Where am I doing it? I'm doing it inside of row, and as we kind of talked about just a minute ago, this is all composition. So the state that is being created by me with all these calculations and that is being read, that DPs per minute, that is the state of that slider, that's all getting read and used inside of composition. And so we're not able to take advantage of those phase state reads. And so it recomposes every time, whereas with my custom layout, I have shifted all of that math, that calculating X and Y's to that measure policy. And so there's nothing in my composition other than, hey, here's some sessions. So that's the power of it from a performance perspective. And just giving you a quick look there. Yeah, so I've transferred all that over into my custom layout, and that's why that is. And that's the power of, again, state hygiene, but just at a little deeper level. Knowing what state is read where is one of those, really important practices that we have to do in Compose. And as you can see here, it's really, if you're really stuck in a situation like this, it can be truly helpful. But it is not just performance that makes custom layouts so helpful. It can be also just to do things that are hard to do out of the box, which is typically, honestly, why I generally reach for them. So let's say I have a screen like this. It's a detail screen in that canonical list detail pattern that we see all the time, especially since Material came out. Now let's say I have this, I have some text, I have a hero image, I have a title, and I have this floating toolbar. This is a little bit Material 1.0, but let's say that my designer wanted this toolbar with the heart and the share icon. They say that they wanted that vertical center of that toolbar actually to match the bottom edge of that image. It's very Material 1 where we have the fab kind of floating there, yeah? If I wanted to do this in Compose, it might be a little tricky, and I'm sure maybe in your early Compose lives or even your now Compose lives, you've tried to figure out how can I do something like this. We don't really have a way of centering like aligning the center of something with the center or the bottom or center of something else. So here's my article header here. This is the image, the title, and the toolbar. And this is just a very naive, let's call it, implementation where everything's there. The floating toolbar is not where it's supposed to be. So if I wanted to center that, maybe I would do something like, oops, is that the one? Nope. I might do something like, here, let me close this and comment that out. Okay, and then I'll comment this in, and I'm going to run it. So I might do something like this where, okay, what is it that I'm trying to do? So maybe to solve this problem, I will make the top padding of that floating toolbar just enough that it shoves it down. Now, that sounds a little icky to start with, but if we know the exact height of the image and we know the exact height of the toolbar, it's not the greatest feeling thing in the world, but it works and it's accurate, right? And so how might I do that? Well, I need to know the height of that image. So I know I've done this and I've definitely seen this. We might do something like this where, okay, we want to capture the height of this image. How can we do that? Well, there are several callbacks that are available as modifiers in Compose that allow you to know when things have been laid out or the size of something has changed. So I have here on globally positioned, and I'm calling that on my image. And so when that image's position has changed, we'll get this callback, and I'll take that height that is given to me through the callback. I'm going to stick it inside of this dynamic state, this mutable state that I have right here. I'm going to calculate some top padding for that toolbar, that action row I called it, add in some extra padding, center it very nicely, and then I'm going to take this padding and I am going to feed it into my toolbar here, into this padding, yeah? That's top padding. And here on my right is where that is, the result of that. It looks great, perfectly aligned, beautiful. I could do this as a custom layout. And this is, again, this is primarily where I use custom layout, is to do something like this. And I know you're saying, well, why would I use a custom layout? That worked really well. I'll tell you in just a second. But let's just confirm that this is going to be this is not going to be very dramatic, slightly anticlimactic. But if I have a version here, that is a layout. And as you can see here, I've got my layout composable. I've got my composition phase and all my other phases. And I'll go ahead and run that. Oop. And because I have an extra, there we go. Live coding is fun. All right, this shouldn't be so dramatic. Works the same. So what's the difference? So the difference is that, oh, actually, we want to go to the documents for this. So there actually is a section of the Jetpack Compose phases documentation right here. And there is a section in that documentation that talks about something called recomposition loops or cyclical phase dependency. And if you look at the code, it's pretty much the example I just gave you, where we want to position or lay out a text relative to the height of an image. And here they're using on-size change, but it's like the same idea, right? We're saving some measurement of this image into dynamic state and using that to lay things out. So where does the problem come in? So there's a really great chart here, and which is why I'm showing the docs, because I could never make a chart this pretty. So what happens, so say initial composition, that first composition frame. We go through composition, figure out what's in our UI, and when it comes to layout, the image gets laid out, we get the height for that image, and then we save that value, of course, inside of our image height pixels. And what happens is, because we're referencing that image height pixels again in our composition, in this example here, you can see it's referenced here. This is composition. So because state that is being read by composition has changed, it's going to immediately re-invoke the reader and immediately start a second frame of composition. And it's only in this second frame that we finally have the full proper height of the image and we can actually complete the rendering of our UI. So we've induced this dependency. We are dependent on an extra frame to actually complete rendering of our layout. So again, I just told you a few minutes ago, like one extra composition here or there, not a big deal. Why is this important? Why does this matter, other than the fact that the documentation tells us that it is important? I'm going to actually give you a very specific example of why this can, how this can affect you. Does anybody out there use paparazzi screenshot testing? Raise your hands. Okay, I do as well. I love it. You can actually run into problems if you use a certain kind of code and have a certain situation. And I actually ran into this to work where I couldn't use paparazzi screenshot testing because of cyclical phase dependencies. Let me give you a different example. Let's say that I am working on a magazine app where maybe the content within my app is laid out using a grid system. So grid systems are just like this kind of like design technique where you have like different rows and columns that define a layout. Material had some articles on it or documentation on it, so something like this. You define a bunch of rows and columns, and the idea is, okay, I want to align content within those rows and columns for making very consistent layouts, for readability, for aesthetics, right? So say I'm building components. I'm building canonical components that will be reused in my app, in my design system, to help facilitate this kind of layout. So maybe I create something that is a very simple horizontal division where the job of that horizontal division is to lay content out among, lined up to a certain number of vertical columns. So say like this top half here, I've got a horizontal layout, it's got 2 sections, and it's divided into the start section where maybe it's aligned along 3 columns, and then the right side is aligned along 2 columns. So this is like about a 3 column width, and this is about a 2 column width. So I might do a very naive implementation like this, where here's my horizontal division. I have a composable that defines the start content, a composable that defines the end content, and then I have the start and end columns that define, the alignment of those 2 pieces of content. All right, let's try this with using dynamic state. So what I need to do here is that now that I know the start and end columns, I need to divide the actual width of that horizontal division among those columns. So let's try to use on globally positioned, save the width of my row, and then do some math to to divide that as appropriate between like the 2 halves and however many columns they are aligned to. All right. And then I have a vertical division which does the same thing, saves the height, but just does it lining it up the other way. All right, what can happen? So, as I said, a cyclical phase dependency in the examples that we've seen, basically increase the number of frames that you need by 1. That doesn't seem so bad, but this is a layout. Layouts get nested. Layouts get nested a lot. And as you are nesting layouts, if you're having this kind of cyclical phase dependency on each one, you can imagine that those dependencies start adding up and adding up and adding up. And it's so funny because a lot of people, again, I totally understand that if you want to just be as straightforward as possible when creating composed layouts, but when you're using just rows and columns, imagine when you just use rows and columns, how many times that gets nested. And so if you start having to do more complex logic like this, how many times do we actually nest in our everyday life, and what can that impact be? So I actually have a paparazzi screenshot test that is pretty straightforward. It is taking a doubly nested, so this example that you see on the right has, three nestings, and so I have a screenshot test for a double nested layout, and I have a screenshot test for a triple nested layout. And if I actually run paparazzi real quick, hopefully it worked before, but whenever you have a presentation, things just happen. All right, so I have 2 new generated screenshot tests. So here's my doubly nested layout. Okay, everything looks fine. Here's my triply nested layout. Oh my gosh, what happened? Okay, what happened was, because this is triply nested, I now have 1, 2, 3 extra frames that are needed to fully render my layout. So paparazzi usually uses that initial composition to take a snapshot. J-Rod, who's over there, I can see you, was very nice and gave us a little bit of a buffer in kind of allowing a little bit of wiggle room in that kind of condition. But We can't be like, hey, JRod, can I get like a 3 buffer or a 4 buffer instead, 4 frames, 5 frames? That's just not scalable, right? So as you can see here, even though the code, the original code is very straightforward and it works, there are certain decisions that you can make that have this like weird runaway effect. And at my current project on my job, I'm doing SDUI, server-driven UI. So I'm dealing with making canonical components, but that I really don't have control at even compile time of what these layouts look like. So I actually ran into this specific situation at work where, okay, we have a canonical layout. It is using a dynamic state. But because of the way that we translate the markup on the server to compose components, I'm now getting just tons of cyclical phase dependency. So none of our paparazzi tests were showing up. So we're actually not using paparazzi right now. And we basically put ourselves in a corner because this is a canonical layout. It is not easy. Our flows are used in several very business critical parts of the app. So we can't just refactor it. So it's not just necessarily performance or the fact that you want to be as close to the documentations as they would like you to be. These will have real impacts on not just like on your app's performance, but your own performance as a developer and your productivity and tooling. And in fact, if I look at the previews for this, and sometimes it behaves. I actually will sometimes have the previews messing up on me. Of course, now that I'm in the actual talk, it's working just fine, but I was prepared for this. It works better on Otter, but previously when I would look at previews, and this still happens every now and again. It kind of depends on whether I restarted recently, I think, or how much RAM is in the IDE. The previews will sometimes just look like this, totally blank. Oh, and there, see, it just disappeared, literally right here. So again, could you imagine having all of your nicely set up previews and just having them disappear randomly or sometimes show up? Again, it is not just that it's a good idea in theory, but these tools are made to work in a composy way. And as much as it, like it can be, it is a real pain sometimes to do custom layouts, but as we bend away from the way that Compose works, sometimes we bend the way that the tools we have built around it, that have been built around it, work as well. And just to hammer that point home, in the documentation, in that cyclical phase loop section, there is a very kind of good summary. I'm just going to read it to you. I know it's bad to read text off the slide, but I think it's really important. So the general principle here, and why you should avoid these things, is that the general principle is to have a single source of truth for multiple UI elements that should be measured and placed with regards to one another. And I think that is so cool because it aligns with the whole reason we have Compose, yeah? In the old view system, every single button, text edit, drop down, every single widget had its own internal state, right? It was its own little state machine. And you could build an incredibly complex, say, form where this validation depends on that thing, and you need to make sure that this is in the right state. And coordinating dozens, maybe hundreds of state machines is really hard, to understate it, right? And is a source for a lot of bugs. So that's why Compose is so great. We live in this, in the year of our smartphone 2025, or in the year of our Android 2025, we are in a world where we predominantly, work in architectures like unidirectional data flow, where the idea is that, okay, the rendering of my UI should be determined by a single solitary state, like a snapshot. And what I want is just a stream of data, a stream of snapshots, and I just want my UI to be shallow enough that it just barfs up the right amount of pixels for that given state. And so it is that single source of truth. And what I think is cool is that the documentation is basically relating that inside of each individual composable, or rather a container. It makes a lot of sense that if a composable has children, we want to maintain this idea of single source of truth. So if elements need to be laid out and positioned relative to each other, there should be a single source of truth for that. And that should be the composable itself. So when we introduce these like dynamic states and everything, we are basically breaking that principle. We're creating multiple sources of truth, which is where some of the problems come in. And so the documentation ends with using a proper layout primitive, or I'm very excited to read this. Creating a custom layout means that the minimal shared parent serves as a source of truth that can coordinate the relationship between multiple elements, and introducing a dynamic state breaks this principle. So I'm very excited that the documentation is telling you, please use custom layouts, but you don't have to. It says they're proper layout primitive. So what I want to tell you is that, even using something like, that might feel, a little more simple, like the box with constraints is, for this situation, a proper layout primitive. You don't have to go full ham and go with custom layouts. So box with constraints is really interesting because what's happening with that cyclical phase dependency is, again, I'm kind of crossing the boundaries of different frames, right? I'm trying to wait for one frame to be able to provide a value to another frame. So I could actually create my, this grid system canonical layouts with box with constraints, because what it's able to do is provide the min and max width and height to its children during composition, but it's the same frame. So there's no crossing of frame boundaries, and so you do not have that cyclical phase dependency. And the previews always work on this one, and I guess I can probably try to prove it to you real quick. If we go to my screenshot tests, go to the code, we can comment out all of these tests there, and then comment back in the box with constraint versions. I'm going to run Pop ROC one more time. Oh no, what happened? Of course there's an error. Where's that? Ah, thank you very much. Beautiful. Glad it was simple. Appreciate it. All right, run it one more time. All right, and let's look at the screenshots. All right, it was that triply nested one. Hey, they're back. All right, and that's good. And that wasn't, again, anything with custom layouts. Thank you. Wow, people really love screenshot testing, huh? So again, just following, just being a little more composy re-enables an entire tool, an entire practice that we can do. So I just want to hammer it home that, again, it's not always about performance. It could just be about your performance as a developer. So I wanted to go into a little bit of subcomposition, because what happens here inside of constraint layout, or box with constraints rather. I'm saying constraint layout because John and Nicola over there, hello. So inside of box with constraints is this concept of subcomposition. So the reason that box with constraints can offer this max width right here is that subcomposition has this power of being able to take those three phases, composition, layout, and actually interleave them so that you can compose and lay out kind of more like subsets of the composables within a composable and interleave their phases. It's kind of weird, but kind of awesome. So what's happening within box with constraints is it's actually kind of going through its own layout phase before it actually composes the children inside of it, and it's able to kind of pass that information there. So I have an example, and this is actually why I'm excited, because I use this for work, which is always really fun. And so this is going to be a little bit of this example is a lot. So what I have is, let's call it the concept of a viewer app, right? So I work on SDUI, so a lot of times we're loading content into a composable, and again, as I've mentioned several times, to my stress often at work, I don't know what the UI layout is at compile time. In fact, I really don't know it at runtime, because we don't really do UI reflection, and we can't really take a composable and break into it in the same way that we could do with views. We just have to deal with it. And so what I have here is something like I do at work, where I have my detail view from before, but that's actually sitting inside of what I'm calling the viewer component. So the viewer component can load up different content. Maybe it has an article, maybe it has like a grid of photos, just different content. I don't know what it is. And then my viewer also has its own UI elements. It has a bottom bar here. And sometimes I might want to be cute and put seasonal things. So this is happens. So even my content here that lives inside of my viewer, maybe I have designed it such that, here it's over here in the preview, that I can swap out different types of bars, different types of bottom content, along with the variable and dynamic actual content that I'm loading. So you can see here that I already have a problem. I don't control this content. I don't control this photo grid. I don't control the layout of this article. And what's happening is that I'm actually occluding the article here. So if I had a simpler design, I could just add some padding here and push this up, right? And this is literally what I had to do at work. The content has this very subtle background gradient, and the ask was that, okay, We don't want any of the foreground elements to occlude the content, but we want to have that design system mandated gradient go all the way to the bottom. If I push this up with padding, then I just get a white space here, right? It doesn't look good, the designer's not happy. How can I do that? So I do have to make some compromises, and what happens is I do need some way to, even though I can't, say, reach into this amorphous like content blob that I have, even though I can't reach into it and massaging the components, I could say create what people at my work call a lever. It's basically a parameter that I can say, hey, you create whatever content you want, but here is some content padding that will need to be interpreted by you as space at the bottom. That could be just a plain old spacer at the bottom maybe for my photo grid, like down here, or for my other example, maybe it's not necessarily padding directly at the bottom, but maybe the content has some padding, the scrollable content has some padding. So what I've done, and let me switch to a different version of my viewer, is, so let me close this up. So rather than using this implementation, let's go down here, and I'll show you how to do this a couple different ways. Actually, we have 10 minutes left. Okay, I'm going to skip, because we already know now that dynamic state reads are bad. Let's go right to my sub-composition version. So what I've done here is I've changed that slot. So the slot before, which is a plain composable, no parameters. Now I'm saying, okay, whatever content comes my way, I want an additional parameter here. I want to give you some content padding, okay? And that content padding will be handed to this content, which has the job of interpreting it however it needs to be. Now, we want to avoid cyclical phase dependency, but we want to have this incredible flexibility. And the way this is going to ultimately work is that, again, my bottom bar content will be dynamic. I don't know what that could be either at runtime. It could be the smaller toolbar. It could be that larger, cute ticket like image that I had, but I still want the same contract to exist. I still want to be able to pad all that up and make the content not be occluded, whatever that means. So I have here my subcompose layout. So I mentioned that you can interleave things. So what I really want to do in this subcompose layout is I want to be able to measure whatever this bottom content is here. So I have this bottom bar slot in my slot API. I want to be able to compose that. I want to measure that, but I want to be able to, in the same frame, take that measurement and use that in the composition of my content. Because this content padding is a parameter into the composable itself, that means it's automatically it's necessary at composition. So I don't just have you can see now how the dependencies have now gotten very complex, right? Because I'm actually crossing not frame boundaries, but phase boundaries for elements in the same composable. And I can actually make this happen with subcompose layout. So subcompose layout, if we go back and look at, say, where was I? My schedule. Here, all right. So we look at layout. It has 3 parameters, as I mentioned before: content, modifier, and the measure policy. And content is where composition happens, measure policy is where layout happens. If I look at subcompose layout, there's 2 parameters only. There's no content parameter here. Where does composition happen? So what's really cool and interesting is that subcompose layout puts the onus on you to generate those measurables, to define what is composed and to run composition on it and to get back those measurables. And so for my bottom bar, which I want to compose first, is right here. So I'm calling this method called subcompose. Subcompose is a method here. It takes 2 parameters, slot ID and a content slot. All right, so slot ID is really just a tag onto that particular composable. You don't really have to worry about it in everyday life, but it has to do with identifying a certain composable, something memorization, and being able to track the same composable across recompositions. It's used specifically for, say, lazy row, lazy grid, where you have indices and scrolling and all that. Don't have to worry about it, but I'm a very anal retentive person, so I always specify it. So I give it a slot ID, I give it my content, which is my bottom bar, so that's directly that parameter from my slot. And what happens is, because when composition is called on, a composable lambda, it's possible that multiple UI elements are returned. So the return type is a list, but is a list of the familiar measurables. So now we have our bottom bar measurables. And again, it's really just one in this example. But if I was trying to just treat it as a list, I might do something like kind of go through, measure each of the measurables in this bottom bar measurable, and then I might calculate the bottom bar height as the max height of the one measurable in there. So anyway, at the end of all this, I have my bottom bar height. So bottom bar is composed and it's measured. We can stop there for a second. And we can now go to my main content, which again, I have to be agnostic about, and which does have that one lever, that one parameter of my content padding. And this is where it kind of gets both cool and a little bit weird. So I'm calling subcompose. Now, this subcompose again has a slot ID, and I have the second parameter, which is this composable lambda here. Now, I need to take that bottom bar height that I just calculated, add a little extra padding to it, and then what I do is I take that content from that parameter, which again is a composable function type but with an extra parameter, and I can invoke my content composable with that content padding into it during this composition phase, which is really cool, right? So the bottom bar, I just like literally transferred the composable from one to the other. Now I can actually massage the composable a little bit, which is really cool. And then typical things that we're gonna do with measuring the measurables. And now we have both so now we have the bottom bar composed and measured, we have the content composed and measured, and now we can place it. And what's really cool is that not only is this a little more efficient than having the cyclical phase dependency, but because with dynamic states, you have to make sure that you have that modifier callback on there, I was having to do weird things like add extra parameters so that I could hook on a modifier that specifically had the callback, but because, into my, content that I need to be a little bit agnostic about. So sometimes it also helps to kind of clean up the API a little bit here. Put that back, perfect. All right, and it's going to error somewhere else before this runs. There we go. So yeah, we can clean up our, is that it? All right, here. And so hopefully this works. Oop, there we go. If we hit viewer. Oh, I know what I didn't do. So, oops, don't send. No thank you, Adobe. So I did add that extra parameter into the content. So content padding here. And then again, I need to have so these two, which I normally wouldn't know about, are my two types of content. And again, this is part of that contract that, hey, you need to be able to take some content padding. And at work, we do this in a little more dynamic way, but it's kind of just right here, hard-coded for you to see. And there we go. You can see here that now I have that extra space added in here, but the content is still able to go all the way to the bottom. And if I switch it to the photo grid, you can see, oh, cool. So I'm able to fulfill that contract. I'm able to avoid cyclical dependencies. I'm able to continue to be agnostic and allow varying kinds of content that do adhere to that contract to work. So again, subcomposed layouts are not something you're going to use every day. It's not something you're going to use every quarter, but it is a really cool tool to have in your tool belt. The documentation on advanced, advanced? Here we go. Advanced layouts and compose gives some very good guidance on it. But just to summarize, if you have children in your layout and one child's layout depends on another child's layout, just use the regular custom layout that we've talked about, because then you can kind of just, you can just be in the same layout phase, for example. But if you have an example like this, where one child's composition depends on another child's layout, where again, we're crossing phase boundaries, that's a case where you use subcomposed layout. So again, these are not things that I would even recommend that you do on a first try or even every day. But I think what's really fascinating, what I've learned a lot, especially at my job now, is that building apps and specifically building UIs is not a straight line. We don't go from requirements and Android best practices to a beautiful, immersive, immersive, delightful UI. Very often we're getting pulled by, say, design and products that they want us to do a certain way. Maybe we get pulled by legal because they need the text to show up in a certain way or always be visible. And then if you're at a place where you have to worry about metrics, oh my God, you have to be pulled this way. And oh, by the way, monetization, so we have to do something about like view impressions, so you need to make your code work a certain way, right? And at work, this very awful dance got me boxed into a corner where I couldn't do things like screenshot tests. So all I really want to tell you or give to you with custom layouts, with Subcompose layout, is moves. Building software is not, unfortunately, a very discrete equation or a math problem. It's more like a dance. So if you have people pulling you one way or another way and you get into a corner because, oh my gosh, we need it to look this way, I want you to have moves that allow you to do this dance so that you can, if you get in a corner because, oh my gosh, they're asking me to do this weird thing, you can spin and, hey, get out of that corner where you can't do screenshot testing and you can dance your way to a beautiful UI. And that's what I have for you today. Keep these tools in your toolbox, keep these moves on your repertoire for your dance cards, and yeah, enjoy the rest of DroidCon.
It's the Androids Baker.
Okay, only a minute over. Hi, how are you? That is a fabulous sweatshirt.
Thank you so much.
Are you okay? That's like halfway on and off. Hi.
It's the Androids Baker. Troy's Baker. It's the Troy's Baker.
Nicholas.
Hi everyone, very happy to be here in DroidCon London. We're going to present to you something we've been working on for the last couple of years. Still interesting stuff, I think, for a lot of you. So I'm Nicholas. And
I'm John.
So if we talk about user interface, specifically as Android developers, you're going to think about your UI as part of your application, right? It's in the same process, etc. And what we're talking today is kind of taking that UI and moving it outside of the box of your application. And other environments like the web, that's pretty much what we're talking about, right? But on Android, it's all together. But in fact, even on Android, we tend to do a lot of things outside of the application that somehow comes from your application, like the notification, or casting your screen, or simply the widgets. And so, pretty much, Remote Compose is trying to provide a good answer to all of that in a very unified way. So this gives you a quick sense of the type of capabilities that we have with Remote Compose. So we do support theming, some interesting graphics effects, components, user interaction, and all of that contained in Remote Compose. And when we talk about UI, we're not simply talking about, hey, just here is your, the description of your content and that's it, it's like an image. No, we're talking about something that is modern, that's flexible, that supports user interaction, resizing, theming, animation, live resize, adaptive layout, this kind of things, right? So we're not just emitting something and always calling the applications. We are building essentially a bundle that's going to be completely self-autonomic, right? And pretty much, it's a binary document. In practice, it's more like a serialization format, but the way you can think about it is, it's a blob. And what we're building with Remote Compose is the entire creation and visualization pipeline for that blob. So we have a bunch of libraries, both to create as well as to play this content. Just very quickly, we have a procedural library that's a KMP library, so you can actually use it beyond Android. You can use it on server side. We have a Compose library that provides something very familiar. We think it's probably the library that you'll use the most familiar with. That's also the one that allows you to reuse the existing tools that we have in Android Studio. And finally, if you've been using Glance to create widgets, an upcoming version of Glance is going to emit Remote Compose format. And then on the play side, we have a couple of interesting stuff. We have an Android View player, so it's an Android X library that allows you to instantiate a custom view, essentially, that can display a Remote Compose document. We have a Compose player, so that does the same thing, but kind of properly within your Compose application. We have an upcoming desktop player as well, so you can actually display that content on your laptop. And finally, we have a widget support. So since Baklava, we actually provide a new remote view that under the hood is using Remote Compose. And that's what allows us to deliver widgets since Baklava that use Remote Compose. Quickly talking about the features. So the idea is to have something that is self-contained, that we can send to somewhere else without having to do a bunch of requests. It's all self-contained. We do also support referencing external assets, but it's a very powerful and very convenient manner to just ship everything together. It's a binary format, and as I mentioned, it's not just like a list of draw instructions, like a display list, but it's also not an application. We're not trying to build a small application, but we're trying to build a bit of some autonomic kind of user experience that you could somehow send somewhere else. More importantly, and you'll see why, it's small. And we're trying to do a lot of work to make sure that the resulting document, the resulting binary, is quite small. It's also small not just in the format and the resulting document, the players themselves are small, both in size and in memory as well. And you may have heard people say, speed is a feature, right? In the similar way, I think small is also a feature because suddenly you can access a set of scenarios that before you simply could not do because whatever solution you would use would be just way too big for that scenario. So keep that in mind. In terms of what it does, very quickly, you can think about it as all the canvas operation you have on Android. We support that. On top of it, we built a component system, quite flexible. We have an expression system that lets you create mathematical expression as well as some kind of evaluation at runtime in the document, animation, path morphing, accessibility, some input. So there is a lot of stuff you can do with this format. Quickly on the components, and that's pretty much why it's being called Remote Compose. It kind of follows the Compose model. So it should be relatively familiar to you, as at least at the conceptual side of it, because we're talking about box, rows, column, modifiers. It's very familiar. We have some built-in layouts like those three, but we also have a couple more, specifically the collapsible ones that essentially will show an element if there is space to show it, and that allows you to build like something that is very flexible and that can expand the content that it shows to user depending on the available size. We recently are working on custom layout, in fact, and we have like default animation. So just to give you a sense of it, this is just a very, very, very basic demo, but those are 3 buttons. I know I'm going for shooting for complexity here, and when I click on it, I change the size, but you notice that, in fact, without doing anything else, there is an animation that's being done. If I press on this one, the button disappears. I press the second one, the button comes back. We have, as I mentioned, an expression system. You can think about it as a way to bind some specific runtime variables to your document, like time or even sensor data, like the gyroscope. But you can also do interesting stuff with mathematical operators, access to arrays. So it's not exactly a fully featured language. It's not meant to be, but nonetheless, it's very convenient. Let's go with a quick walkthrough of the code.
Yes. So here's a very basic hello world. It's not composable. It's also a remote composable. So you could actually have something that is both in that sense. You'll see remote box instead of box, remote text instead of text. Pretty straightforward. And if you're familiar with Compose, this should look really the same.
And notice that you do support the existing tooling. So here I was just showing the interactive preview in Studio. So you can easily test your code if you're using that particular library.
And in this particular case, we're using a canvas and we're drawing a line. It's pretty straightforward. We're getting the width, getting the height, and drawing it with offsets. This is a compose one. Now, if we have a remote compose one, you'll see it's a remote canvas. And the remote .component.width for the width and the height, and you're using it. But what's happening under the hood here is very different, because what happens is expressions start to get inserted into a document based on the run of this. And so by the end of running this, you have a document that specifies all the lines and everything and expressions that do the math, and we'll see more of that later. And just to show you side by side, the only thing that is different is the remote component width. And some of the APIs are still evolving in terms of trying to find what exactly we want to use as the API. It's pre-alpha, so. Now let's go to a more complex example and take you through it. And first we'll go through one that is in the remote composable. And now you see it's pretty much remote modifiers and remote box and remote canvas. Notice you're seeing more and more complex expressions. They look like floats or something, but in fact, these are remote floats. And they're evolving in expressions, and when you go use them inside of a draw line in this particular case, or rotate, those expressions get inserted into the document. So they get sort of lazy inserted into the documents. So those are expressions, and they are our canvas operations. And if you look at the math in here, you'll see you're taking the time in hours and multiplying it by 30. That's a rotation angle. That's the hour hand. And then we have the minute hand. And just for fun, I did the second hand in a little bit more, not rotating the frame, but actually calculating the math of it. And so you can do all of that math. It still works out as an expression. It still does everything the same. Now, in this particular case, we're switching gears a little bit and showing you the lower level creation library. It's in Kotlin. It looks like a little bit like Compose, but it's actually much more direct in terms of as it executes lines in here, it's writing lines into the document directly. So you have a root, you have a box, you have a canvas, but these are not, you notice there's no composable here. But the math looks the same, and you can do the math and stuff. A difference here is that you'll start to see things that are like paint. So if you're familiar with doing canvas operations at a views level, this is views style where you have a painter. A lot of that is about efficiency. You want to be very, very compact and elegant. One of the principles here is any float you see in our API should be replaceable by an expression. So you can vary anything, and that turns out to be hugely powerful. Again, the same math, the same draw calls, but the paint is different. And you can sort of see, you can pick and choose which commands in the painter so you can keep it compact. So it's a very compact, and here's that same piece of code running in Baklava as a launcher widget. So it's viable today.
So covering a little bit, because we're covering a lot of ground, in a short amount of time. So trying to give you a little bit of sense of all those different bricks are fitting. We can consider a few examples, right? The way we're thinking about Remote Compose is actually something very flexible, much more than even those examples. But we have to start somewhere. The first one is launcher widgets, right? Like what you can see on your launcher. The way we implemented it, because it's in remote views, it actually is compatible with any launcher. It's not just the Pixel launcher of Google. And this, on the flip side, is tied to the platform, right? So you have some interesting aspects around like compatibility and stuff like that. But all in all, like starting from Baklava, you can as we showed, like kind of start to use some of those features. The second one that's a common scenario is a server-driven UI. And by that, I mean you have an Android application, you want to actually download some of your UI from a server. And so this is the scenario where the server is going to create the UI, serve it to your application, and you want to display it. But all the needs that we have are the same. We want a modern UI, we want animation, we want all of this, right? And compared to other other solutions to the server-driven UI, we think that this solution is going to be smaller and more efficient and more integrated with the Android system, like, for example, like a direct integration with the accessibility, etc. All of that, by the way, and this is kind of why we're doing this talk here, it's still relatively early. It's literally pre-alpha in Android X. So we're kind of hoping to get, people feedback on all of this, and etc. A third one that I think is quite interesting as well is if you have two applications that want to not only talk with one another, but kind of exchange UI, right? It's actually a surprisingly common case, even though it feels a bit strange, but there was no good solution, right? And so Remote Compose, is an answer to that. You may notice that in each one of those, the transport, how you send Remote Compose, is actually very different, right? Like for the widget, we're using the remote views, therefore we're using a binder call. For a server-driven UI, you're going to use some kind of HTTP request, etc. So this is one of the key things with Remote Compose. We're focusing on building all the features to create and to play, not so much for the transport. Because in fact, one of the ways we think we can unify all of those different scenarios is because typically they tend to differ with how you transport the information, as well about how you handle the life cycle of this content. And so we decided to say, not for us, but we built it in a way that it's very easy for you to plug into whatever is your transport mechanism. And so to cover those little examples, all of those artifacts are AndroidX libraries, right? So we have a bunch of libraries for the creation and a bunch for the play. If you're looking at widgets, typically you are going to be able to create your content either with the lower level procedural API that John showed, or with the Compose library that John demonstrated as well. You also have a third option, which is using the Glance library. Like an upcoming version is going to support emitting remote compose, as I mentioned. And all of that starting from Android 16 and plus. If you are using the more server-driven UI kind of scenario, at the moment, you have to use the KMP library for the creation, so the kind of procedural way of creating the UI. We are looking at bringing the Compose library to it, but right now it's only on Android. And otherwise, to display it, my typical recommendation would be to use one of the AndroidX player library in your application, because that way you also control which version you want, new features, bug fixes, and all the good stuff.
But one of the things to realize in that is that once you create the document, you don't really care how you created the document. It's just a document. It is very self-contained. It's where it came from doesn't matter, and you can create it 2 weeks in advance, and it doesn't matter. It's just sitting there doing nothing. You can play it.
Yeah. All right, and to finalize, if you have some kind of cross-application collaboration going on, then of course you can use also the Compose library, and you can use either of the Android players. All right. I think we're ready for demos. We tried to go as fast as we could for the context. Hopefully you have a vague idea of what we're talking about now, but now is the more shiny stuff. So I mentioned the component support. So this is an example of relatively basic UI, but it's an UI that demonstrates several interesting stuff, like live resize, animation, and all of that. So this is actually running as a widget in that demo, but you can see that the UI is going to properly reflow, resize, hide element, show element. And again, none of that involves a call back to whoever created that UI. That UI is running completely autonomously without any callback to the application, which has a lot of advantages because in the case of widget, your application might not be running, period, right? So you have lots of interesting stuff. Just to show you that, when I'm saying we have stuff going on that are work in progress that are interesting, we have the same stuff but working on my Mac here, right? Because it's all pretty self-contained and I can run it. Need some work, but we can expose like some interesting graphics primitive. I mentioned, pretty much what you have on Canvas, we do support. I'm not lying, we do have graphics layer support, so you can build some interesting stuff here. Notice as well that here I'm having some interaction, right? It's not just some document that you are reading, I'm actually playing with it. We like calendars. So this is another example of a calendar, but this one has shaders, right? And so you can see that the background colors is dynamically changing and is slowly animating and etc. So you can do a lot of interesting graphical stuff. And talking about graphics.
Yes. So I mostly work on the canvas layer right now to make it suitable for animation. And so you can draw a square, but you can move it in 3D if you want. We have matrix support within the document format. You can you can build a graph and animate that graph. It could be, all the kind of modern graph looks you can build with it with what we have. So you can do lots of interesting things.
And what's interesting on this one, because it's not just we built a graph that's a drawing that's fixed. This particular example actually take a random set of data and build and construct the graph on the fly, right? So it can be very flexible.
Yeah. So you can imagine situations, and we'll demo it eventually, where you can send the data separate from the document, and so that you can actually have, here's a graph, and now here's the data for the graph, or I want to update the data for the graph. Here's a particle system. So you can build, we actually have a built-in particle system, and particle systems kind of tend to be thought of as really fancy, but in the context of a document like this, particles can be super important for achieving sort of graphical effects that you might want to kick off and some sort of activity for. So we have quite a lot of support for particles. And here's another example where we're interacting with the walls, and you'll see it sort of wall shifting because if you're on your phone, it's detecting the gravity, and if you shift left and right, the balls will move with the gravity and bounce around. So you're capable of building very interactive, very complex user interfaces. Here's a use of the particle system and the shaders. So it's taking the output of the particles and running it in shaders. Nicholas wrote the shader for this one.
I like shiny stuff. So talking about all of those scenarios, DOS tends to be hopefully something that you might find interesting because it tends to be related to Android. But fundamentally, that system is not specifically tied to Android, and specifically we try to make it so that you can easily port it to other environments. I showed you on the desktop, for instance, but there are other use cases. So we'll try like a live demo, and hopefully everything works. So this idea here is we have an ESP32 microcontroller here, so you can see, and that's not automatically super powerful, not specifically to run like complex UI, but if you see what we have,
you operate the
yeah. I'm going to move the potentiometer, and you can see that the UI running on the phone connected through the board shows the difference when I operate the potentiometer.
So what's important here is that we have a document on the ESP32. So it's a microcontroller, and it's sending the document to this via Bluetooth. It receives the document, and then every time it changes its signal, it updates the document, and it can send deltas. You can choose whether to send the whole document or deltas. And I mean, we're showing it as a kind of a oscilloscope kind of graphing thing. Yeah. But any small device can now interact with your phone.
So, but what's interesting here is the ESP32 does not have to know anything about the document. It just has to encode and to add the data to it, but without knowing the document. We literally finished this demo yesterday night. So we did not add a couple of stuff, but we could have totally added, which, for example, we could have added a couple of buttons to zoom in and out from the document perspective. Again, we could have supported zooming without the ESP32 knowing about it. But we could also have done the other way around, encode some action in the document and send it to the ESP32 to change some stuff. So all of that is possible. Talking about, outside the box again, you may be familiar with this kind of cards, right? NFC cards. And we were kind of wondering, like, how much we can put on it, right? And you have different type of cards. Those are run-of-the-mill, like 1K cards. And 1K give us like about 700 bytes. And we can actually put stuff on it, right? So if you see the screen, and it's not a reference to a document that we download. The entire document is in the card. Let's do a clock.
Yeah, so that's the same clock example. Now we're just running as a...
Maybe the particle engine, if you have it.
Yeah. So particle system running in...
So, John, do you think that remote compose might be interesting to people? Hi, we have one last demo. Hopefully it will work out. How much do you fit in a QR code? About 2K.
Surprisingly.
So let me switch to iPhone here. going to start that, and you know, it's live. Say hi to the camera. All right. And I have QR code here. See, it's a piece of paper. So let's do it. Yeah. All right.
Yeah. So
Do the next one.
That's literally the data for the document.
Yes. All right.
Yes, thank you.
And the last one. And you can see here that I can use the phone to control the gravity.
Yes.
Yeah.
Okay.
Up.
Yeah. I hope we've sort of convinced you that it's a very small and flexible format. And these demos you see here were done in the last 7 days. One of the nice things that we had in here is that you can say, oh, I'll build an intent where if I send an intent, I send a document, I'll display it. And then when I wrote a separate program that was a QR code, read the QR code and fire the intent. And so you can divide and conquer, and it was very simple to put together, take an NFC reading and fire the intent. The one with this is a little bit, with the Bluetooth is a little bit different because you want to be live updating in a high throughput, so you need to wire everything up without intents.
Yeah, but you could do interesting stuff like, imagine you could essentially create the document for that UI of the ESP32 on your phone, send it to the ESP so that it can store it to send you back or to another phone, right? So there's a lot of interesting scenarios. Yeah. That kind of concludes the talk. If you're interested, it's all actually available on AndroidX.dev as snapshot. We are kind of pre-alpha. Feature-wise, we do a lot already. And you know, part of it is we already kind of shipped it without anyone knowing in Baklava, right? API-wise, you know, we're still iterating on it. So we are very, eager to hear feedback, both in terms of features, if we're missing something, as well as API, right? So we are literally right now working on iterating on those APIs. If you want to contribute, you can also contribute. There is a couple of people that started to send CL, so that was kind of nice. Remember, small is a feature. Feel free to contact us on social networks, and yeah, we are happy to take any questions. Okay.
Okay. Any questions?
Yeah, we need to wait for the microphone.
Oh. You have to go to the mic.
Does it support versioning of documents?
Good question.
That's a good question.
So there's two layers of versioning. We're gonna make sure that with the players are always backward compatible. So inside the architecture of the player side, when the document comes over, it says what the document has a version number, and if it's a version it knows, it'll be able to play it. And there's some interesting little tidbits in there as to how it does that. So it always stays backward compatible. On the front end, when you're creating, you can say, I want to create for version 6, which Baklava is version 6. If I say I want to create for version 6, then you will, if you try to make some weird call that it doesn't have, it'll throw exceptions. That's not available in version 6. In some cases, we re-engineer a new feature in the client library. So, you say your version you're 6, but you try to make a call. We still may support that call, and what you'll see under the hood is we'll replace that call with a bunch of other calls that actually do the same kind of work as the previous one.
Yeah, we kind of took a page out of the Compose playbook. we try to build a set of primitives that allows us to extend what is possible by combining them in different and interesting ways. So we do, we didn't go into too many details here on how the document is organized, or more exactly, it's more like a streaming format. It started as a literal live streaming UI. Technically, it should still support that, but we found more interest into moving to that, intermittent update of things. So that's why we now consider it more as a document. But internally, it's still a series of operations. Yeah. And so the main difference that's going to happen with future versions is more capabilities, more optimization, but all the basics that we showed will be compatible going forward.
Yeah. There's also a little versions in terms of where you're sending it. So for instance, we disabled in Baklava shaders. So if you try to write something with a shader, you'll just get this red triangle unsupported API. Sometimes you can put one in a notification because they do notifications or remote views. Notifications are a little bit different in behavior, and so you might find if you want that, make sure you test it, because you'll be surprised at the differences in what a widget looks like and what a notification looks like. And if you're doing peer-to-peer, you can turn on shaders, or you can disable shaders, and you can do whatever you want at that point, because you're in control. The peer that is receiving and hosting the player is the one that's actually in control of what gets played.
Yeah, and for some of that, we are going to support it in the upcoming version of Android as well. Like shaders is one of those where we didn't have time to enable it purely for security reasons, not because it doesn't work, but we are hoping to be able to enable it in upcoming versions.
So also a question about versions, but more about Android versions.
Mm-hmm.
So you talked about Baklava and you talked about widgets in Android 16. So how do you plan going forward? So coming about new APIs, like the upgradability of the views inside of Android. Do you plan to make those upgradable?
So yes and no. That would be the ideal, but it's not that straightforward, right? So we're kind of working toward that, but it's not there. So in the meantime, we structure the format so that it can, even if things are not updated like that, you can still manage to get an amount of compatibility. As I said, it's going to be more like about performances, because let's say that we have a new feature. That new feature might actually be available in previous version, simply expressed as a series, as a set of the existing operations. We can't do that always, but in a surprising amount of cases, we can do that, right? So you have to distinguish between the compatibility of the operations and the compatibility of essentially the front-end API, right? And we think that we'll be able to support essentially more and keep the front-end API going forward. In an ideal world, we would have it completely updatable on Android side. But in the meantime, what we are doing is, essentially it's tracking the tip of tree. So what's in the platform is about what's in tip of tree on the libraries.
If we grow enough in popularity and people start using it, I can imagine a point in time where we started think about Google Play Services versions and things like that support the 8 But right now we're sort of in the beginning stages of this, where we're looking for places that various groups, like Otto and Where and all of them are looking at using Remote Compose. But as it grows, we'll see how it all plays out. Okay.
All right. Cool. Well, it was great presenting all of this to you. Feel free to talk to us afterwards or to ping us, online.
Yeah.
Thank you. Yeah.
Thanks. Very good.
1, 2, 3. I can hear my voice. Yeah, nice and by the way, this mic is very good level. Can we replicate? Because yeah, that's a very good level. Can we replicate that level on the Countryman, whatever you call them, headsets? Are they okay? Okay, perfect. Thank you. Thank you. Thank you.
There's no one over there. You can tell someone from the group, so they'll just cover you. Okay. Yeah.
We don't have slides.
Yeah, that's a good point. Yeah.
Hi there. Are you part of the staff? Yes. I wanted to do a request to show this while we do the intro, and then I will cue. Yeah. Okay. What time is it? Sorry. Okay.
Thank you. Sorry? Oh, yeah, good point.
Okay, hello.
Yes.
So we don't have any slides, but we're going to show the laptop.
Hold up.
Okay. Yeah. So the request was let's keep the slide that is on right now until I say let's move on to the laptop. Is that okay?
Where we'll be sitting. Thank you.
All right. That's all I wanted. You know, we don't want to show the laptop for the whole interaction.
Sorry?
Exactly.
2:35. Yes.
Awesome. That's perfect. Thank you very much. Okay. Bye.
Rehearsing things.
Perfect. Thank you. all set.
Okay, nice.
Smile, have fun.
Don't ever tell a woman to smile. More.
I downloaded the app and I can't find this agenda. Can you
How's my hair?
send it to me and it doesn't
Good,
come?
yeah. Is mine too nuts still? No? Okay.
Right?
There's this weird in-between spot between hair looking crazy and stylish and hair looking crazy and just like homeless person.
I see.
It's very subtle.
Yeah. So in the outro, you stand here when I talk.
Yeah, I'll just move away.
Okay, we hope this talk gave you practical insights into the Android native features of Android Studio's agent. But we still have a long way to go, and we're always trying to push the envelope. And for that, we need your feedback. That's the spirit. See? I don't want to be part of this.
Thank you.
Oh, that would be nice. Yeah. But later.
Okay.
In the evening? Yeah, exactly.
Sounds a bit weird, but fine. For all possible, yeah. Yes, exactly. True.
Yeah.
17 alternatives?
Yes. On average, but then
Except
a week.
for there's no internet.
Oh, yeah.
We don't know what to do.
Could you just like hotspot?
Yeah.
Please, no,
Yeah, we
have
actually we should try.
We have Ethernet connection.
Yeah, but
Like you mean the conference Wi-Fi?
No.
They say it's a dedicated network for.
It's still it's a dedicated network.
Yeah, no. That one was so slow. No.
It's dedicated, but with the same
But yeah, but we should have a hotspot.
Find a way, nudge Siva while we're doing the demo. I'm just saying, Tor got his own custom build, so Tor builder. Yeah. Tor Canary. The overloaded one? I haven't gotten that one in a while, thankfully.
Manolo.
Overloaded, exactly. Overloaded.
It's the cloud key. It's my own
You did?
cloud key actually.
They were? Really?
I have a legacy cloud project assigned to some NTV group that I don't know.
That's weird. Okay.
Nowadays.
That's really weird. At all.
It is very helpful, yeah.
They have been changing a lot of things on the go. Like they just removed 2 chairs because they realized it blocks the view for the recording. And I was like,
No,
there's
it just
a lot of sessions.
just goes somewhere. Yeah, I don't know where it goes.
Do a
That would
voice. It
be
was a
amazing,
warning.
yeah. I wouldn't even know what to do.
You can do a voiceover.
Yeah, especially because yeah, we're using the clipboard already.
Yeah.
So, but yeah, we should have a second one. We actually prepared for that, but I don't think we implemented.
Thank you.
Thank you.
I thought I saw Yuri Vlad somewhere. I wasn't sure if that's him. Okay. Oh, he left. Oh wow. Okay. I thought he was gonna be a Bumble forever. Basically, he was like the stick. Okay. Got it. Okay. I thought he was still in. Because I think his bio said something like around Bumble still, so I thought he was still there. But yeah, it's the second time.
In Spain, right?
In Spain.
7,000 per month. 4,000 here, but that's 4,000.
sound engineer.
Time is it? Oh, 2 minutes left.
Okay, let's go up.
Really? It's 2 minutes left.
So
You want to
yeah.
go up? Okay. And stare. Here.
I want to get this over with as soon as possible.
You just want to start right away.
Yeah. Do you want to put that paper back down?
Yeah.
Or?
Actually.
But I don't, because the camera is not busy. What people need all the
And to
time.
look tall.
Huh?
Because
Need to
without
look tall.
sound, you cannot
Okay.
hear what people say. But they don't need camera all the time. Because without camera you can still see. But you cannot hear because it's... Huh? They're gonna stream tonight. But see, without the stream,
MCP server
without
off.
the sound, nobody can see their laptop, and nobody you cannot hear from here.
Oh, holy shit.
Sometimes they don't need camera very often.
So what?
It
Would
was
that
on.
be a problem?
I mean, if it's
For you?
Yeah. Open Figma.
Sometimes they put it on screen. But
Okay.
the best.
Did you select it?
Yeah. No. Just, I don't know if that's gonna change things, so let's just keep it.
No, I need to get more experience on camera before you use the sound. Yeah, I need to get experience. And then go on a course as well. On a course? Oh, like online training, not online. You cannot learn online. If I show you the rack behind, you cannot learn that online. So you need to put
Wojtek isn't here this year? No?
No, it was his dad's birthday today or something.
No, cute.
proper expensive equipment. You cannot learn it online.
But do you own something like this, like this?
I have my camera. That's not my.
Cool. Okay. Hi, everyone. Welcome. My name is Simona. I work as an Android developer relations engineer at Google. I work on Jetpack Compose and Android Studio UI tools.
And I'm Jose Alcerrica, also Android Developer Relations Engineer, working on developer productivity.
So, thanks for coming to our talk today, where we'll share with you many new and improved features of the Android Studio agent, how these features can assist you in your daily workflows, and how best to use them to get the most out of them. Now, our goal is pretty straightforward. We want Android Studio to have the best AI agent, the most knowledgeable one, and the one that's truly helpful for Android development. That's why we're focusing on creating features and tools that you can use and trust enough to delegate those more repetitive tasks to, so you can focus on the more exciting bits of Android development. That being said, today we're going to show a lot of live demos that depend on AI models and features that are experimental. So, you know, live demo, AI model, experimental features, it means that pretty much anything can happen. So we might need to tweak it here and there and help it out and improvise a bit. So we appreciate your patience while we do so. But before we dive into the live demos, first we need to go over some theory concepts, things like tools, MCPs, context, and similar, and then we'll understand enough to actually go into the live demo. Over to you.
All right, let's get started, and if we can move to the laptop. Thank you. All right, so what I have here today is Android Studio Canary. It's almost the same as the one you can download today. It has an extra feature that I'll tell you about. And we're going to be focusing on the agent, and this window here is the main UI for the agent. You can open and close it with this icon. All right, so the agent is not only a chatbot, it can only perform tasks, complex and simple. So I can ask, what's today's agenda? In order to do this, it needs a large language model that you can choose here if you have an API key. If not, you can just use the default model at no cost. All right, so in order to understand the basics of agents, we first need to talk about a couple of concepts like tools and context. So something that we're going to be mentioning all the time in this talk are tools, agent tools. Tools are what make an agent different and what make Android Studio's agent special. So if I run this command /tools, we can see the list of tools that are available in this agent. So you can see tools like write file, version lookup, read file, etc. So what is this? One of the first things that the agent does when you start a new task is it sends this list, or one very similar, to the model. It's basically saying, hey, if you need anything from me, just let me know. I will run it for you and return the response. It's the model who decides which tools to use with which parameters and what to do with the response. That's very important. So with this, I can start asking questions like, what's the theme defined in this project? It's important to note that the agent doesn't send your whole code base to the model. That would be incredibly wasteful. Instead, it sends this list of tools and the prompt, and then the model needs to decide how to solve this problem. In this case, it did something very smart. So it used, decided to call the find files tool with thin_kt as a parameter, and that's how it found the theme. This is because the model knows that most Android apps define their themes in a file that ends in theme.kt. So this is pretty smart. But every agent can do that. So what about what's the latest version of Lottie? This is where things get interesting, because we are mixing the power of a large language model with the power of Android Studio. Android Studio already has a feature, a functionality to do version lookups. So we're exposing that tool as one of the agent tools to the model. So the part that is missing is what's the actual artifact of Lottie. I just said Lottie, but Gemini, in this case 2.5 Flash, already knows what artifact I'm referring to, com_rb Android Lottie. And this is how we got to the right response. Okay, so let's move on to something a little bit more real world, although not fully. Let's say that you are in the middle of a task, or rather the agent is in the middle of a task. So let me open this file. And let's say that it's done coding this repository here. And it wants to run the unit tests for it. How do you get to the task that you need to run? A generic agent would probably run all the unit tests in the project, which is really wasteful. I mean, potentially that's thousands of tests. So let's see how the agent would deal with this, or the model in this case. What Gradle task should I use to execute the tests that cover this class? Or something a lot less verbose, for sure. Again, we're not reading any files. This is just leveraging all the internal tools that are exposed by Android Studio. Tools like get Gradle artifact from file, get unit test for artifact, and finally get test task for artifact. I don't actually know what they do, but what I do is that it gets the right results. It's actually, this file is in the data module, and it's only available in the demo debug variant. You don't have to worry about these tools. You don't have to memorize them. But from time to time, it's useful to type /tools to see what's available and what makes Android Studio's agent a little bit different. OK, so we all expect the agent in Android Studio to be really knowledgeable about Android. The problem is that large language models are trained with existing data at some point in time. So new libraries, new best practices are not part of the training, so the model doesn't know about them. Also, they are language models, not encyclopedias. But it turns out that if you complement a model with some knowledge, or a way to find that knowledge, then the accuracy improves a lot. So we created something that we call the Android Knowledge Base. It's a collection of documentation articles from the Android docs, Firebase, Google developers, and also Kotlin Lang. And it's exposed as a tool. It's actually exposed as two tools. So we have search Android docs, and then there's another one called fetch Android docs to fetch individual articles So I can ask something like, tell me about navigation 3. And something very interesting happens. The model knows that it doesn't know about navigation 3. So the first decision that it makes is, I need documentation. I need to look for a little bit of information about this. So it decided to use the query navigation 3. And the results include short descriptions. That's how it's able to infer this very good response of what navigation 3 is. If you ask something like, migrate my app to navigation 3 or whatever, it would probably fetch individual guides from the knowledge base. This has big implications because now you can use the agent with new APIs like Android XR, the new Gemini APIs, the latest version of Compose, etc. A tip that I want to share with you here is sometimes the model doesn't know that you're referring to new APIs. For example, you're asking it to do some Compose code, but it doesn't know that there's new APIs. Just add to the prompt something like check the docs. That's enough to trigger this tool call, and it gets much better accuracy. We're still tweaking the tool descriptions and the system prompt to see how much to call this tool, actually. All right, so that's some integrated tools that we have. But aside from these, there's a way to expand the list of tools. You've probably heard about MCP servers or MCP. This is the way to do it. For example, GitHub has a very interesting MCP server that lets you manage your repositories, issues, and pull requests just from the agent. So you can say things like, grab my latest issue and fix it, or whatever, right? But today I want to show something else. The Figma MCP server is also very interesting. So I have the Figma desktop app for Mac here running. And in here I have a layout. It's just a list of items with a way to add new items to it. So if I go to settings in Android Studio and I enable MCP servers, you can see here that I have Figma already configured. And it's pointing to a local URL. This is because the MCP server is actually running inside of the desktop app. And this is a very common pattern, by the way. Normally, or well, frequently, MCP servers run locally on maybe in a Docker container or a binary, but there's also a way to configure remote MCP servers. The only reason I'm not using that is because I would leak my API key to all of you, and I don't want that. So if I open this screen, I have something similar to what we saw in Figma, right? This is a list of items and a way to add new ones. So now that I have the MCP server configured, we go to the bottom, we see that there's a new Figma MCP server collection of tools, and it has things like get design context, variable definitions, and get screenshot. So let's try to use that. Take a screenshot, let's do it well, of what I have selected on Figma, which is the default. I don't think this is necessary. And convert this screen to look like it. So I'm not going to show this demo fully because it would take 3 to 5 minutes and we have a lot of things to show. What I want to show you is that the Get Screenshot tool is now available after I configured the MCP server, and it's able to take a screenshot from Figma directly without having to deal with exporting to PNG and then adding it to the agent as an attachment. So I'm going to stop this. Simona has a lot better demos, UI demos to show you later. All right, so another important concept I want to talk about is context. As I said before, whenever you start a task, the list of tools is sent to the model, and this is part of what we call the context. But it's not just this list of tools. It also contains interesting information that is generated by Android Studio. If you think about it, every time you open a project in Android Studio, there's a lot of interesting information being generated. So we can definitely leverage that, either through tools or exposing it in context. So the simplest demo I can do to show this is, what is the name of this project? Just to show you that it doesn't read any files because it's part of the context. The response comes back immediately. All right, so what I actually want to talk about related to context is this menu here. It has 4 items. The first one is current file. You normally have that checked. The second one includes the contents of the recent files in the context. And then we have 2 that let you customize the context with the natural language that you decide. So it's agents.md and rules. So let's start with rules. If I go to the prom library here, you can scope rules to the IDE or to the project. So this is a great way to customize the context for you. In this case, this is where I put the agenda in the beginning. It wasn't anything sophisticated. It's just the context that is added to every new task that I start. This is a good place to add something like your GitHub username if you're using the MCP server. Or if you feel adventurous, you can say something like, talk to me like a pirate, or something like that. Cool. Now, what happens if you want to share that customized context with the rest of your team? Well, for that, what we recommend is this new standard called agents.md. So I'm going to open the example that I created. Let me stop wrap that. In this, so agents.md is just a markdown document that lives normally in the root of your project. And in here, you can add some hints to the model so that it doesn't have to figure things out. For example, I have the title of the project. I have a short description. This is very useful because it's useful for the model to know what the end goal of your app is, right? And then some architectural hints, like the fact that it's using UDF or Hill for dependency injection, etc. So I have 2 tips for you regarding agents.md. First is start small. Don't add too much stuff to agents.md. This is sent to every single task that you add. Just add things when you see that the model is struggling to find things about your project. And the second tip is you can add agents.md files anywhere in your project, in any directory. So the way it works is it takes the current file and it browses all the way to the root of the project, looking for agents.md. So for example, you can have an agents file in the data directory, and then if you're editing a file in the data module, then it will be added, as well as the root agents.md file, of course. Okay, so with that, we move to demos. And the first one is half a demo, because I don't have time to show it completely. And this is something that we're working on. This is not available yet, not even in Canary. And it's a way to create new apps from scratch using natural language. So I can come here and say something like, create a calculator app. Optionally, I could attach images, would be mocks of the UI or whatever. Then I will give it a name, and off it goes. So this is great for prototyping, for trying out new libraries, for reproducing bugs, things like that. And the way it works, let me rearrange all of this. The way it works is first it creates a plan. It has some features, the tools and the libraries that it's going to use. It also generates the tasks that it's going to run. And in here, this is your opportunity to say to add more tasks or more features to it. So you can add things like, include UI tests or whatever. So for the sake of the demo, I'm just going to say looks good, and off it goes again. And now it's going to start doing all those things. Oh, it's asking me something. Okay. Sure. So this takes around 15 minutes. Obviously, we don't have time for that, so I'm going to stop it. It works most of the time, actually. No, it's hard to believe, but this planner thing makes things a lot more reliable. So you have to trust me when I say that this other project was generated with exactly the same prompt like 3 weeks ago or something like this. It's not perfect. Something happened with the 0, is got stung or something. But I'm pretty happy with it. I kind of like it now. So let's take a quick look. The the compose code looks good. It's using material theme. It's using content description, what it should. It's sending events to the view model. That looks pretty okay to me. The view model is where the calculation happens, clearly. So, it's pretty comprehensive. And it even handles edge cases or interesting situations, like preventing adding multiple decimal points to the single number. It also generated a bunch of unit tests, actually a lot of unit tests. So, I feel pretty okay with this. So let's see if it works. I mean, I know it works because I generated this 3 weeks ago, but it does, more or less. It converted to float for some reason, but it also even can handle errors. So that's pretty good. But I hear you say, well, this is great, but what I want to do is to modify my existing UIs and my existing app. So that's what Simona is here to talk about.
Okay, let me first start by cleaning up. Okay. What else? Let's kill this one. Okay, cool. So, the features that we've seen so far are either the ones that support you in testing or setting up your code base or updating it. These are the features that we've seen so far, but the features that we also have out already. But we also want to make sure that the agent is a good and trustworthy, helpful companion during UI development, that it's well positioned and well placed from our side to actually solve the problems that make you more efficient. That's why we teamed up Jetpack Compose and its tools, the agent, and the unique understanding that Android Studio has of your code base to support you better in those scenarios where you have to generate completely new features or designs, when you're refactoring or updating existing ones, or when you're just changing an annoying padding. And that way, we decided on the following set of features. Now, we're gonna demo all of them, if I manage to do it in time. The first one is Transform UI. This, by the way, all of these features are available in Canary, so you can try them out. This feature, Transform UI, lets you use natural text prompts to actually describe the changes that you want and then let the model handle them for you. The next one is Match UI to Target Image, which uses an uploaded image or a new design that you have to better align your existing UI with the dedicated, the new design. Next up is Fix UI Check Issues. This is a new feature that leverages the existing UI check mode to detect potential UI issues and to offer code fixes automatically. And today, aside from these, we will also show a few more, which you can find in this. This is a completely new feature, generate code from screenshot. Basically, it creates completely new code and completely new components based on an uploaded design that you give it. And another one, let me just show that one. So as I mentioned, right-click, generate code from screenshot is here, but above it, you'll also find another feature called Compose, generate compose previews. Now, this takes over the repeated task of writing previews for you. Now, Transform UI and generate previews has already been out there, so you might have tried it before, but recently these features, along with all of the other ones, got powered by the agent, which means that the agent is able to execute slightly more complex plans, split them up in individual tasks, and hopefully provide better results. Okay, I think that is it for a bit of an intro. I think we can start with the demo. Okay, cool. So we have one of our Compose samples open here, Jetlagged, which has very distinct theming and styling. You might have seen it before. But today, we want to actually generate a completely new screen for it. Now, this is a very simple mock for a setting screen that doesn't currently exist in this in this code base. So what I'm gonna do is try to generate it from scratch using the generate compose code from screenshot. So I'm gonna give it this screenshot and give it to the model to start working on it. So while the model is figuring out what to do, usually how this starts out is the model starts laying out a plan of what to do and how to solve the task you've given it in the best possible way. It starts invoking tools, it starts thinking about which tools to invoke to solve this problem for you. Now, usually it starts out with some of the simpler ones like reading files or searching for specific resources that it thinks it might reuse, and then goes towards the more complicated ones. It also tries to come up with the best placement for your new code, so it tries to see which files or packages are the best suited ones. And it also tries to reuse things like existing components or best suited resources. Now, here we see that it actually started with some of the simpler ones like reading files and searching for one of the back arrows resources, but because it didn't find it, it actually realized that it should probably create one. So it went to create this kind of a back arrow resource. It did mess up the color here, which it would probably change on iteration, but honestly, I do not want to wait for that, so I'm just gonna give it a bit of a nudge. Thank you for that. So while it's still working, it created like a vector resource that it thought would be the best fit, and then it continued on working with the rest of the code. Now, once the resource was added, it starts continue to look for other things that need to be changed. Now, hopefully, it'll generate the rest of the code soon. Okay. While it's still going, there's, like I mentioned, like there's a few tool calls that tend to happen at the beginning, but then towards the end of the task, okay, great, good timing. Okay, cool. So we see here that there's a mock of a screen that I've given it. Looks fairly similar to what I wanted it. There's tweaks here and there that I wanted to create, but I'll kind of move on to that in the next phase. Once the agent has kind of finished with the initial task of adding the code, it moves on to certain verification steps towards the end. Now, once it's kind of, okay. By the way, I also have auto accept changes enabled here, so I just want to make sure that I don't have to accept it every single time. Once, this is quite slow. Okay, brilliant. So it added some of the changes already, the ones that it thought were needed for completing this task. And towards the end, it needs to verify whether this code is actually being built and whether it's in a good state. So it calls a very unique tool called Analyze Current File. Now, this tool is actually the one looking for any errors that the IDE has already reported. So things like syntax errors or unused imports, deprecated APIs, anything that it can catch beforehand before running a more costly Gradle build. Once it actually calls these tools, it goes into the fixing and iterating mode, and it fixes its potential issues. This tool is, like I said, a lot easier and it's kind of simpler to run before a Gradle tool, and it's a good way to catch issues beforehand. Now, I think I'm pretty happy with this design still. The model might go through several iterations of fixing its issues or trying to align your designs with what you've given it. But for the sake of the demo, I'm quite happy with this, and I think I'm going to move on to the next step. Okay, so another quick thing that I just want to verify is whether like the model was also doing some like basic state handling for these things, like switches and stuff like that. Seems to have done a good job. Okay. I'm happy with this. Let's move on to the next one. So now we have a design in place, and in a lot of the times we have a new requirement from our designer, a new design that comes in midway, and we need to change the UI of our existing feature. Now, if we need to kind of refactor an existing feature and better align it with some of the given mocks, for this specific use case, we actually have another feature to help you out. So I was given this design. It kind of is slightly better aligned with the theming of jet-lagged apps. So I'm actually going to give that to the model and see what happens. So to do that, I'm actually going to use the match UI to target image feature. So I'm going to give it the new updated design. and I'm going to send it to the model to see what happens when I request this. So again, most of the times the model actually tries to lay out a plan, figure out exactly what needs to be done, lays out a plan for you to as well follow the steps of all of the things that it thinks it needs to do, and tries to kind of figure out the notable differences between the existing component and the desired image. As you can see, you can follow some of these steps as well in these kind of pop-ups that keep on changing, and it goes into the tool invocation mode while it's still doing that. In previous turns, we saw the analyze current file as one of the verification tools, but we also have a few more that are able to kind of help you out during this kind of landing phase. Let's go. Gotta pay the demo tax at some point. Okay, perfect. So it went in, made some changes to kind of match it better to the design. And I can see that it's actually looking a bit better and more aligned with what I had in the designs. There's some tweaks here and there that I want to do, but again, I think I'm going to actually leave that for a later stage. Great, okay. I think this is what I wanted. Perfect. So once the design has been added and the bigger chunk of the work has been done, the model thinks that now it's kind of ready to show you the results of its work. And for that, it calls this render compose preview tool. Now, this tool actually shows you the results of the agent, and it also does some verifications basically to check if the Nuli code is actually compiling and whether the preview is successfully rendering. So, and it displays it within the chat tab, well, the agent tab now. Cool, okay, I'm pretty happy with this as is right now, and I think I'm ready to go on to the next part. So now we have one kind of preview that was generated with the initial part of the code. I hope you can see everything. I don't have a lot of space here to show you. But yeah, it generated the default theme for the entire screen, which is great. But our Compose best practices also say split up your Compose UI into smaller nested components because you're going to get the better reusability and testability, and generally they're going to be able to preview easier. So it did just that. It divided them into kind of more sensible, well-rounded Compose components. But now that I have this, kind of screen-level preview, I want a few more. Now, a few times during this talk, what we said was, basically we said that we want the agent to take over from you the more repetitive tasks and parts of Android development. Now, I love Compose previews. They're, a super useful tool, but writing preview after preview after preview is not really something I'd call at least exciting work. So in order to do that, what I can actually use is the generate compose preview AI feature to help me out with this. So one of the things, okay, so it starts out again similarly laying out a plan for you, trying to invoke specific tools to finish the task successfully, and then it goes on into the actual implementation of the code. Now, one thing that I also want to show is this, one tip is actually if you're not sure, if you have auto accept changes like I do, and you're not sure at which point the code might have been added, or you just want to see it in isolation, you can also use this kind of diff editor view to ensure that all of this was added properly. Okay, so it added the code, it called a few tools again to verify whether this was successful, and it actually added the preview at the very bottom. Now, this is a very simple component, right? So the preview isn't that difficult to generate, but aside from that, what I wanted to do is to actually generate all of those mock data that I need for the preview so that I don't have to write it on my own. It's a bit of a tedious task if your composable is massive and it takes in a lot of mock data. So this kind of helps you out with this. Aside from that, it also handles things like wrapping it in it tries to follow the existing patterns that you have in your code base. So it looks at the appropriate theme, and because I kind of used this show background already, it thought, okay, maybe it's smart to actually follow this pattern and use the same one. So, okay, I'm okay with this. I think that's pretty cool. But the next stage in the development is usually, tweaking your existing UI to better accompany it, to better follow certain designs. Now, for this specific screen, I want to change a ton of things. Like I want the toolbar to be aligned at the center. I want to change some of the strings. I want to make fonts bigger. I want more spacing. I want a pastel gradient background, etc. So I could do all of this by hand, and obviously I could start, going around the code and chasing where I need to do this. But because I'm able to kind of verbally express what I want, and maybe, I also want to have a bit of fun and see how it looks like, I actually can verbally express it all in this way. So because this is left, I'm going to change it to center. I've kind of pre-written all of these requirements that I just told you, and I'm actually going to use another feature called Transform UI with Gemini, which lets me use this very verbose prompt with a lot of changes, give it to the model, and then see what it comes up with. So I'm going to send all of this to the model. As you can see, you can read through all of these points and all of these smaller tasks that I wanted to build and do for me. And once it kind of, ingests the request that I send it goes into the editing mode. So it goes through some of the tools you've seen before, which is the read files, editing files, and things like that. So I personally, this is one kind of informal tip. Personally, I really like to use Transform UI when I actually need ideas, like visual ideas. This means, because I'm not really good at design, by the way, this is one of the phases of the agents. It makes a mistake, and then it goes into the actual iteration mode to try and fix it itself. Because I'm not good at design myself, I kind of sometimes can explain what I want to see, but I can't really make the design for it. So Transform UI is really helpful there because it kind of lets you explain what you want, set into the model, and get some visual ideas of what your design could look like. Now, while it's still working on these iterations, you can see that it started adding some changes. It started changing some of the typography, and it ran a build which failed. So now it's going to go into the mode of iterating through it and trying to fix it. Seems like it's still trying to fix that. Okay, perfect. Fixed all the changes. It added all the bullet points that I gave it. I'm just going to scroll quickly so that you can verify with me. So settings is now aligned to the center. It increased all the fonts. It changed the strings, and it added a nice subtle pastel background. I'm pretty happy with this right now. I think it might go through a few verification steps. Okay, cool, finished. That's great. But now that this is kind of done, I also want to acknowledge the fact that not all changes are going to be this easy. It's not like you're always going to be changing just the padding, but you might also actually want to add a new feature. So for this specific part, you can actually use Transform UI as well. So for example, if I wanted to add a chat fab to the screen without having to think about all the resources and all of the implementation, I can just use Transform UI, explain the feature that I want, and let it handle it for me. All you've seen so far kind of repeats itself, but we go into the tool call, it realizes I don't have a chat icon, tries to create one. Let's open it up. I think this is good. It generated the vector drawable, that's fine, but that's fine. I didn't have to do that, but okay. Cool, okay, so it generated the vector resource drawable because it couldn't find an appropriate one in the existing package. It will do that with other resources as well. It will try to reuse strings if it can. If it can't, it will, try to generate them sensibly. Now, it added the vector drawable. It moved on into the second part, which is adding the actual floating action button. And I think it added it in the proper place, which is within the scaffold. So yeah, I think I'm pretty happy with it. It's showing up on the preview, and I think I'm actually going to stop it right here because we are very close to time. Okay, cool. So now we've done this, but what about the quality of the code? Once your UI is, completed and successfully implemented, you also want to ensure that the quality of the code is also in a good place. So to do that, you can actually you can use the fix UI check issues feature that is actually implemented through that actually leverages the power of the UI check mode. Oh, wrong one. Sorry about that. So UI check mode, perfect. Thank you. The UI check mode is a service that actually goes through your code and tries to find any potential issues that it might have. So things like, potential accessibility issues or issues in other form factors, etc. So right now, it's listed out a few that it found with my design. I'm going to try and make this as easy to see. I hope you can see it, but if I go through some of these, I can actually see that some of these are related to some of the insufficient text and color contrast ratio. So I'm not really, okay, I think I know which one it is, but I don't think you can see it. Okay, perfect, here it is. There's a few components that just have insufficient color text ratio. So what I want to actually do is I want to invoke the fix with AI implementation, the feature that's been just recently added, to try and get this fixed by the agent. Now, you can either start this through the UI check mode, or you can actually go into the composable preview and right-click on that, the entry point that we've seen previously. Because that will take a bit more time, I just want to show you a quick way of fixing these potential issues by invoking the agent. Now, it's going through, again, the same kind of a process. It reads your files. It tries to come up with the best proposal to fix it. And it detected that probably this text here should not be using, should be using a better color to make it more suitable. It actually implemented this change, and it's going to rerun to ensure that this fix has actually fixed the issue. The way it does that is by actually rerunning the same service it ran in the first attempt when it detected these issues, which is the visual lint service. Because we are very heavy on, very limited on time, I'm sorry that this has taken a bit longer than I thought, but as you can see, this color here now is a bit more, is darker and slightly more suitable. Okay, cool. So this was a quick way to try and show you a few new features that we've just added. We went, in 20 minutes, we went from no code, one simple mock, then we iterated on it, added more features, fixed a few things, and hopefully made this app slightly better.
And because we run out of time, I'm just going to say thank you so much. Please send us as much feedback as you can. Use the thumbs up, thumbs down buttons whenever you see them. And we're going to be around in the, in the conference, and we have office hours a little bit later. So thank you so much for coming to our talk.
Troy's Baker. Troy's Baker. Troy's Baker. It's the Androids Baker. It's the Androids Baker. Android's Baker.
About dual booting for testing and curiosity with dynamic system updates. The last slide in the presentation will contain a QR code to this presentation, so you can refer back to any links or any instructions that are given on any of the slides. So, the outcomes of the talk, I will cover what generic system images are, or GSIs, which is the prerequisite knowledge for dynamic system updates, or DSUs. I'll also give a walkthrough on how to apply a DSU to your device, and an explanation on how they can be useful in your development workflow. So who here has heard of dynamic system updates before this talk? So a few of you, but basically it's not your fault if you haven't heard of them before, because Google haven't really made much of a song and dance about it. In fact, the documentation for DSU is on an untraveled part of the Android developers website. So where I got the inspiration for this talk is I'm on a Slack group, and someone posed the following question. If you use Pixel devices for testing, is it possible to go back and forth between the Android versions? Can I flash the latest beta, test my app, and then flash the latest stable again? And I replied, yes, you can, but a better idea might be to use dynamic system updates, where you can have a primary version installed, and you can also have a second installation, a bit like dual booting. And the reaction to my comment was there's 22 people hit the Today I Learned button, TIL. So that kind of gave me more of a clue that not many people know about dynamic system updates. And I want to also thank Eric Hellman for bringing this feature to my attention while we're working on a previous project. So what are dynamic system updates? Well, firstly, we need to talk about generic system images. So what are generic system images, or GSIs? So from the Android developer website, it describes a generic system image, or GSI, is a pure Android implementation with unmodified Android open source code project, AOSP code, runnable on a variety of Android devices. So why are GSIs useful? Well, AOSP is a canonical version of Android, so testing against the AOSP version of Android gives you a baseline for support. Bluetooth, Wi-Fi, and sensors are tricky to test in the Android emulator. There's ways of mocking them, but it's tricky. So if your app supports hardware features, then testing on device is non-negotiable. Some devices can support GSIs from multiple versions of Android regarding of the primary device installation. But we'll come back onto DSUs later because they make the process even easier to flash. So the prerequisites for generic system images is that the bootloader is in an unlocked state. This means that your device will now fail Google Play integrity verification, meaning that some apps, such as banking apps, will refuse to function. So this is not suitable for your daily driver. Project Treble was a project within Android to decouple components within Android. GSI relies on this decoupling to operate. So you can determine if your device is Project Treble enabled by executing the ADB command that's shown on the slide. The device must have also launched with Android 9 or higher. There's some devices that launched before Android 9 that might support GSIs, but this isn't guaranteed. The GSI image CPU architecture must also match the CPU architecture of the device that the image is being flashed to. If it doesn't match, the process will fail. So use the ADB command that is given on the screen to determine what CPU architecture your device is. And I just want to draw your attention to the warning at the bottom of the screen is that flashing an image which does not meet the requirements may result in the device becoming non-bootable, soft or hard brick. So soft brick being that it's recoverable, and hard brick meaning you've literally got a brick. So some device recommendations is, so this talk is mainly going to talk about Google Pixel devices because that's the most traveled route for GSIs and DSUs. So I would recommend Pixel 3 and above for GSI support. These can be picked up fairly cheaply and also secondhand, even more cheaply. Perhaps even look at the Pixel A series as an inexpensive device to test on. Other OEMs do provide support, like for example, there is support within Samsung and some other OEMs as well. But I've only tried the instructions given in this presentation on Pixel devices, so I can't vouch for compatibility elsewhere. But do refer back to the prerequisites in the previous slide to give you a clue if the device will support it. But also just have a look online to see if other people have had a success with this as well on the image that you're interested in using. So how do we obtain a GSI? Well, Google has these official releases that are at the URL shown. They come in the varieties of pure AOSP code or the ones where it's AOSP but with Google Mobile Services already installed on the image. There's also ci.android.com. That's Google's public view of their continuous integration infrastructure for building Android. For some reason, the Android 15 and Android 16 don't show up on ci.android.com. I'm unsure what the reason for this is. And if you have the know-how and a powerful enough machine, you can actually build your own GSI images. You can make customizations to Android or to pre-bundle apps into the image if you want to. To flash a GSI is actually beyond the scope of this talk because we're going to be talking about DSUs. But for interest, there is no single set of instructions. It varies by OEM. Google have a set of instructions at source.android.com about how to do this for Pixel devices. But you also might have some success with flash.android.com. But again, this is going to raise data on your user partition, so don't use it on your daily driver. And it's also the possibility of soft or hard bricking a device if you're not careful. And now on to DSUs, what you came here to listen to me talk about. So what is a dynamic system update? So a dynamic system update, dynamic partitions are a user space partition in Android. The system can reallocate the size of partitions depending on its needs. As long as your device has enough free space, DSUs can make space for your guest image installation. The guest image is installed onto this new dynamic partition that's created, and once the installation has completed, the device can then be rebooted. And if it's successful, you should boot into your guest installation that you've installed through DSUs. If it failed, normally you should just end up back in your primary installation again. But be careful because DSUs can, in some circumstances, cause issues and brick the device. You can also easily switch between your primary and guest installations with relative ease. And so if your DSU image is your preferred installation, you can make it sticky. And we'll talk about that later on in the presentation. But things can always go wrong, so please back up your data first. But as you alluded to before, is that you want to specifically do this on a specific test device. DSU prerequisites. So the DSU featured was added in Android 10. The prerequisites are largely the same for what I covered before for GSIs, and that the device has to be Project Treble compliant. And also the CPU architecture and the image architecture must match too. You may not have to unlock the bootloader depending on the image that you're booting and what key it's been signed with. But I would probably advise you to unlock the bootloader anyway because it causes less problems later on. If the guest image passes the Android verified boot, then it should boot. But if the image does not boot, then you may need to unlock the bootloader and flash a new VB Meta image, but we'll discuss that later on in the presentation. DSUs also include rollback protection. System images that have a security patch, system images have a security patch date stamp included in them. The date stamp on the guest system image must be newer than the date stamp of the image that's in the primary installation. So there's two ways of installing DSUs on the device. There's either using the DSU loader, which is a user interface on the device, or you can use the command line on your development machine. Sorry. So naturally, the UI is easier to use and less opportunity to make mistakes, but you're limited to a small number of guest system images provided by Google. If your needs are simple, then use the DSU loaders images provided by Google, because they're probably fine for your needs. However, if you have particular requirements, for example, if you need to use an image that's not provided by Google, use the command line. Either way, you'll probably need to use the command line to prepare the device for using DSUs. So to prepare the device, these instructions apply to the Google Pixel line of devices. Our devices may vary in their instructions. This assumes that you've already enabled developer options and USB debugging on your device, and that the device is connected to your computer by USB. Don't perform the following steps unless you're okay with losing data on the device. So firstly, verify that you can see your device with ADB. Then reboot into the bootloader and wait for the device to be in fast boot mode. Then unlock the bootloader. After issuing the fast boot flash and unlock command, then follow the instructions on the screen to proceed. This will erase all user data on the device. Now we want to disable verified boot verification so that the guest image can boot regardless of the sign-in key of the system image. So we download a special build of AB Meta provided by Google at the URL that you can see on this slide. And then once downloaded this, we can then flash this AB Meta image using the extra command line arguments that you can see here to disable verity and disable verification. And then the device is now ready to accept DSUs. So you should see a video on your screen here, on the presentation here. If we go to the Settings app, then we navigate to Developer Options, then the DSU Loader option. Then a list of images is presented to you. These will be GSI or GSI plus GMS, and you can choose whatever you want. You need to then agree to the terms and conditions, and then you can monitor the download and installation progress from your notifications. The download obviously depends on your internet connection, but the installation normally takes only a couple of minutes. So once the installation is completed, you'll then see in the notifications restart button, so hit restart. And then hopefully you'll have rebooted into your DSU guest image. And if it didn't boot, then as I mentioned before, you will usually return back to your main installation. This is usually what happens. But be wary of disaster. So if in the worst case scenario, you may soft or hard brick the device. To install DSU from the command line interface, firstly we need to prepare the image. So you obtain the image from whatever source. This could be from the GSI releases page or from ci.android.com, or maybe one you compiled yourself. Before the images can be installed, they need to be unsparsed. Some sources will give you the image already unsparsed. On Mac, you need to use the SimG2 image utility, which can be installed through Homebrew. On Linux, this will usually come through your distribution package manager. On Windows, no idea, but there'll be some way. I'm sorry, I don't use Windows. But if SimG2 image returns an error, this usually means that the image is already been unsparsed, in which case delete the 0-byte file that has been produced by SimG2 image and then rename the image to system_raw.image. And then before we can then send the image to the device, it needs to be gzipped. Once it's gzipped, we can then use ADB push to send the image to the device's external storage. Verification activity is an activity on the system which is used to install DSUs. So to install the image that we've just pushed, we use the ADB command that's shown here to start verification activity, passing in the start install action and passing in these arguments as intent extras to tell it where to find the gzip system image, the size of the non-gzipped system image, because it wants to know the un-gzip size, and what size that the user data storage is supposed to be. The WC command that you can see here, executed in line within the command here, is used to evaluate the size of the system raw.image file. If that doesn't work in your system, you can substitute this with the file size of the image, but the size to pass in here is the byte size of the image. And if required, you can also tweak the size of the user data partition. To install the DSU from the command line interface, once you've done that, you started verification activity. You'll see the installation notification in the notification drawer, just like you did on the DSU loader method. But hopefully there are no errors, but common errors might be that the size of the image is wrong, failed verification, not enough space in the disk. But assuming all is well, like the DSU loader, then you can hit the restart button and notification. Once the device is rebooted, then hopefully it was successful and you're now in your DSU guest installation. So to make the image sticky, by default DSU image installations are not sticky, so if you reboot you'll end up back in your primary installation again. The data is preserved, but however you can enable sticky mode so that you automatically boot into the guest installation on boot. So execute the given ADB command shown in the slide here while you're booted into the guest image, not from your primary installation. And likewise, just like making it sticky, you can also make it unsticky to go back to your primary installation again by executing the free commands that are shown on the slide here. So disaster recovery. So if you do have any issues, then you can employ some disaster recovery techniques. So as alluded to earlier, the process is destructive to user data. So take a backup of your data, but even better, use this on a dedicated test device. Failure should not usually result in bricking, but this doesn't mean it can't happen. Normally, failure should result in you go back to the main installation where you started in the first place. But for Google Pixel devices, Google provides factory images with the flashing instructions for every device that they've ever released. In most cases, this should get you back to a clean factory state if things go wrong. This presentation concentrates on Google Pixel devices, as I mentioned before, but so other OEMs will have their own recovery methods, so please consult your OEM's instructions on how to recover the device. In the worst case, but unlikely scenario, you could hard brick the device, so please be careful with the commands that you're sending. Some tips is that you may wish to move between Android versions. If you do so, then install an old version of Android in your primary installation. This is because of the rollback protection that I mentioned earlier, where it looks at the security date stamp in the image and also the security date stamp of the installation. So use an old image so that you could always pass the rollback protection. As alluded to before, it's best not to use your DSU as your daily driver because of unlocking the bootloader. This disables some device security protections. Also the DSU loader UI will likely present Android build numbers rather than the more publicly understandable Android versions to you. To map between the build numbers and the Android versions, go to the URL shown at source.android.com. Sometimes the instructions in this presentation and the Android developer site don't always result in success for you. You may need to search for help or use your own intuition or give up. Sometimes there's issues. So I'll quickly go through a couple of use cases about why this might be useful to you. So as demonstrated in this presentation, DSUs can make it relatively easy to run a guest system image on real hardware alongside your primary installation. However, beware of some gotchas like images not booting, for example. Don't expect an older Pixel device to magically be able to run the latest version of Android. But nevertheless, using the guest images allows you to access real hardware such as sensors, Wi-Fi and Bluetooth, etc. So this means that you can test where the emulators cannot across different platform versions. As mentioned earlier, AOSP is the canonical version of Android, so you can test against the gold standard baseline before evaluating paired device support. And because you can easily switch between different versions with DSU, it's possible, depending on your setup and needs, to maintain a smaller bank of devices in your test lab, because you can just switch between versions on a single device. Another use case is that when you run a production version of Android, the system is signed with private vendor sign-in keys, and the device is usually in a non-rooted state. However, for testing and debugging builds of the platform, user data or engineering builds, they are usually signed by AOS-provided test keys. These builds are locked down are not locked down as much as production builds and are usually rooted. Many APIs are hidden or restricted by permissions. You can only obtain if you're signed with the same key as the system or if you're considered a privileged app. Because the test keys are publicly in the AOSP repository, you can easily sign your APK with the same key as the user debug built system. In the user debug system, because the production protections have been disabled, such as the ability to access root, you can remount the system as writable, so you can push your APK to the priv app installation location. So why do this? When messing around with a user debug system, you can learn a lot, like I did, about how Android works internally. It's fun and perhaps satisfy your curiosity. And with DSUs, you don't need to worry about breaking anything, because if you mess anything up in the system, you can just return back to the host OS and install a new DSU image and try again. Also, if you're writing system-level services for your day job but don't have access to the test hardware yet, and then the debug, say DSUs with user debug images gives you opportunity to write these system services. This is the whole reason I learned about DSUs in the first place for a previous project I was working on, because we didn't have access to the test hardware, so we used DSUs to write critical system services. So thank you for coming along to my talk. That's the end. And as mentioned, my first Android and Droidcon talk. So thank you very much for coming along. Here's some links on the screen. The first two links are basically show you how to do the GSIs and also DSUs, much like what was shown in this presentation. But the other two links are about how they are implemented within Android, if you're curious to know how it works underneath the hood. And the QR code that's shown on this slide here links you to this presentation, so you can reference the URLs and the instructions. Thank you very much. Any questions? Yeah, I've got to take questions if you want. Yep. I've not actually tried that with Android Automotive. I think it should be possible. The only thing is in the vehicle hardware abstraction layer, how that interfaces. So if you have a mock version of the vehicle hardware abstraction layer, then I think it should work. But I haven't actually tried that specific route myself. Any other questions? Cool. Well, thank you for coming along.
It's the Androids Baker. It's the Androids Baker. Androids Baker. It's the Androids Baker. It's the Androids Baker. Trots Baker. Trots Baker. Trots Baker. Troll's Baker. Troll's Baker.
For a given location when we run it. So in a trivial implementation, we may just take these and make them into properties of the class. Now, you can probably already see some problems here. Maybe our weather service is used in multiple places. We are a weather app, after all. A popular pattern for this becomes the singleton. So it's just as hard to test, but at least now we're limiting instances. If we want to make this testable, though, we have a few options. Maybe we set some, set service backdoor into our test. It's powerful, but prone to leaks. If you have multiple levels of this, though, it pretty quickly becomes unwieldy. Suddenly, they're also surprisingly mutable. And you, the consumer, have to know quite an awful lot about how these dependencies are wired, and only fails at runtime. So maybe we move to using a service locator instead. This could be as simple as get application.getWeatherService. Get application could be any type of service holder. So by injector.instance or by inject or the locator framework of your choice. Locators, though, are still hard to test because you do have to still backdoor it in somewhere. And what's worse is that they're, again, only validated at runtime if they're validated at all. If you're handwriting these especially, you're probably not doing any of this validation up front. So the last and best option is to just make your dependencies a constructor parameter. This doesn't even technically need a DI framework to use it, and is often just called manual DI. In manual DI, we just deal with simple constructors most of the time, and if you know the language, you understand the code you're reading. This is a textbook example of the programming concept called inversion of control, or my preferred description, the Hollywood principle. Don't call us, we'll call you. So aside from the standard language features, the kicker here is that you don't need to know where that dependency comes from or how it's wired up above you. In a test, you just new it up. If you want to fake the data, give it a fake weather service. There we go. Scoping in this case is not the responsibility of the consuming class either, which helps with setting this up in a test. And it's implicitly validated at compile time because you literally cannot compile it if you don't pass these dependencies down. You're not having to go fish things out of a bag at runtime. Manual DI isn't free, though, because we still have all this boilerplate wiring somewhere, and it scales up pretty quick, too. Your service likely needs an HTTP client, which likely needs some sort of cache, and this is where DI framework comes in. So, without further ado, we want to dry this up and introduce Metro. So, Metro is a compile-time dependency injection framework that draws heavy inspiration from Dagger, Anvil, and Kotlin Inject. It tries to unify their best features under one cohesive solution while adding a few new features along the way, and it's implemented as a compiler plugin. So why another DI framework? So I feel like it's felt for some time like the Kotlin community has been waiting for a library that kind of unifies the best of Dagger CodeGen, multi-platform, Anvil's aggregation, things of that nature, and you want IDE support. A lot of people write custom lint checks for this. And you want it to be sort of Kotlin first, like Kotlin Inject does, whereas Dagger generates Java and is often pivoted to be Java first, or positioned as Java first. Different solutions exist for different parts of these, but I don't think that there's been a cohesive compile time solution that sort of unified and checked all these boxes. It's also a lot of domains that I've worked in, and I guess at some point I decided that was me in the middle. So in short, Metro basically stands on top of a lot of stuff that came before it. It doesn't seek to reinvent the wheel in this, and instead tries to build on top of what was already working well and smoothing over stuff that could have been better. The idea, hopefully, is also a one-stop shop, so you don't have to think about 3, 4 different frameworks that are all working together. So to start using it, all you need to do is apply the Gradle plugin for it, and you're on your way. Metro builds on top of established patterns from existing DI frameworks with familiar semantics such as different injection types, providers, multi-binding scopes, and some intrinsic runtime types like provider and the Kotlin standard libraries lazy. Like other DI frameworks, Metro lets you use annotations to indicate dependency semantics in your code directly, allowing you to replace this wiring with just this. The primary entry point here is the dependency graph. All you need to do is define types or type keys that you need, and it'll manage these instances for you. Metro's compiler plugin will implement it at compile time, following dependencies from their roots. Graphs, in this case, are analogous to Dagger and Kotlin Inject's components. Creating a graph is quite easy. It's using a magic typed create graph function. This is what we call a compiler intrinsic, meaning that the source is just a stubbed body, and the compiler actually comes in and replaces this call at compile time. So it's similar to the standard library's typeup function if you've used that. If your graph itself has inputs, you can create a factory interface annotated with @dependencygraph.factory with a single abstract function that takes any input parameters and returns the graph. Parameters must be annotated with either @provides or @includes. Provides annotated parameters will be directly available on the graph as a simple instance parameter. Includes we'll get to later. And then you can just call create graph factory, another intrinsic, and the compiler will replace this with a call to the created factory implementation. So how do we get other bindings into this graph? So if you, the simplest way to provide a binding is what's called a provided binding. It's an overly simple name, but it's just a function on the graph that we annotate with @provides. And this can return whatever type you want to stick onto the graph. That type is then available to anyone else on the graph. Provided bindings can also have dependencies. We just add them as parameters, and Metro will stitch them together accordingly. Providers can also be inherited from supertypes, allowing you to define common interfaces and reuse these in different graphs as needed. If you want to provide multiple instances of the same type, you can disambiguate them with something called a qualifier annotation. So qualifier annotations are meta annotations, meaning they are annotations that go on other annotations. A convenience built-in one is called @named, and that just takes a string argument. The pair of a binding and type and its optional qualifier is what we call a type key. And Metro views every binding on the graph as a type key. What is a binding? Inside Metro, each type key on the graph is modeled by what we call a binding. We've covered one type, this provided binding, and we'll cover a few more in a bit. Binding, in this case, is a managed instance that we have keyed by its type key, and a dependency is any binding that is depended on by another binding, and more about the relationship between the two. Most of this talk will talk about things in terms of bindings. Now let's look at how injection works. So if you own the class, you can actually skip provides and just annotate the class directly. The typical way that you would make a class injectable and available on the graph is to just annotate it with these @inject annotations. In simple cases, you can just put them directly on the class itself. If you have multiple constructors, you can also annotate a specific injectable one. This, in turn, is another binding type we call a class binding. Now, this gets us pretty close to our original sample. And in this trivial example, this alone isn't saving us that much code. Where a framework like Metro or Dagger or Kotlin Inject, etc., really shines is where its native features start making the tedium easy. So let's do that, starting with scoping. So like Dagger and Kotlin Inject, Metro supports scope annotations. These indicate the scope or the lifetime of a binding, and it must match the graph that they attach to. That is to say, this tells the compiler to ensure that only one instance is ever created for the lifetime of the graph that it's included in. So first, our graph must declare its scopes. These are also meta annotations, and Metro's standard scope annotation is just @in, which takes what's called a scope key k-class argument. Metro also supplies a common scope key class. Sorry, word soup on these. And these combine to make @in, app scope, and we just stick that onto our app graph. Single-in is lifted from Anvil and is essentially Metro's analog of Dagger and Kotlin Inject's @singleton. It's a little more explicit about the scoping, since singleton in this case really just means singleton within that graph. So I preferred this name rather than offering a first-class singleton annotation directly. Note that our graph also declares scopes. We can use scope, and this is required in order to use scoped bindings within that graph. Going back to our example, scoping the weather service like we needed before is now actually just as easy as adding a scope annotation directly onto our class. The scopes are a single instance within the lifetime of the app graph, and anything in the app graph or its extensions will always get the same lazily initialized instance of our weather service. So, like Dagger, all bindings and graphs are unscoped by default. Scoped bindings are lazily initialized with thread-safe, doubly checked locking. There is no single check or reusable option in Metro. There's an FAQ about it, but basically boils down to not feeling like it was super necessary. Scope is declared at the binding site rather than the consumer needing to know about it. And certain binding types can't be scoped, and we'll mention those as we go through them. So we've covered class and provided bindings. One unique thing that Metro can do is that these can be private. So in source-based code gen like Dagger or Kotlin Inject, everything in the compiler, everything that the compiler generates has to be able to access whatever type it's invoking. So your constructor or your provides function, which means that they need to at least be package accessible. Since Metro operates as a compiler plugin, we can actually modify the code directly. So let's cover the remaining binding types. Next up is an optimization called @binds. Just like Dagger, these are callables that are like aliases. They're just a simple abstract function or extension property that act as a pipe to say that this binding is actually just an alias to some other binding. Metro never, or as such, they must also be type assignable. Metro never generates any code for these declarations and uses them purely as compile time signal. Since they're just an alias to their alias type, they also can't be scoped independently of it. This is something that Dagger allows. I found it a little bit complicated to do it and wanted to keep scope in the original site. Common use cases for this include binding implementation types as interfaces that they implement, binding types into multi-bindings, we'll get to that in a bit, binding types as nullable variants, because Metro is Kotlin first, it also understands Kotlin nullability as a first-class feature, and you can also bind types to other types with different qualifiers. Next, let's talk about assisted injection. So in some cases, you may have a class that requires a runtime dependency to be instantiated. So for example, consider an injected user repository that needs to know about a user ID in order to be constructed. We could put this ID on the graph, but it's not really something that we need on the graph. We may also want to create multiple user ID or user repositories for different IDs. So to support this, Metro has something called assisted injection. And to do this, you mark which parameters are assisted with this @assisted annotation. And then we add a simple factory interface annotated with @assisted factory that has a single abstract function with matching assisted parameters. We also disambiguate these injection types with a slightly different inject annotation. Instead, we use @assisted inject. And that's valuable for the compiler to know when we're using these types that we can't actually depend on them directly, but rather that they have an associated factory that we should be using instead. These parameters in the assisted factory must match the constructor's assisted parameters, and this SAM function must return the assisted type. And with this, you can now inject this factory, and Metro will generate code to handle shepherding the assisted parameters to the constructor injected type. The last major binding type is multi-bindings. Multi-bindings are just collections of bindings that are aggregated either into sets or into maps. Contributing is easy. We just annotate a given provider or class binding or binding with either @into set or @into map. The underlying binding on the graph for the final collection is created automatically if any of these into annotations are present, but you can also declare them directly with an @multibinds annotated declaration in your graph. The Metro compiler will implement these getters as well, so you can just call them directly. One notable difference from Dagger is that Metro will error by default on empty declared multibindings, and you have to opt in to allow empty ones. For map keys, the keys must be statically defined at the binding site with a map key annotation. Map keys are the final meta annotation that we have in Metro, and you can define custom map key annotations with it. There are, again, some built-in ones here like class key, string key, etc. If you have a collection you want to contribute into a set, for example, another set, you can also use @elements into set to contribute them all at once. Next, let's talk about aggregation. So who here uses Anvil or Dagger Hilt? So good, 50% of you or so. So Metro has Anvil-style binding aggregation built in as a first-party feature. What this means for those not familiar with Anvil or Hilt is that you can basically slingshot contributions or bindings from some other module to a destination or component or graph that you want to host those bindings. With it being a first-party feature of Metro, there's no needing to have intermediary like @merge component annotations or anything similar, nor do these tools need to try to preempt the graph generation by running at some earlier stage of the compiler or the build. So for example, Anvil had to work by operating in the capped stub generation step so that it would get a chance to run before Dagger's annotation processor could run. Aggregation works by what we call aggregation scope keys. These are actually the same keys that you would use with something like @single_in, allowing for some shared semantics. And this is the Metro way of saying aggregate all bindings contributed to this scope. In fact, if you declare an aggregation scope, then you don't actually need to include this @single_in because Metro will actually treat it as implicitly added for this case. So what's a contribution? Well, there's 3 types. The first that we want to consider, say you have a graph that wants to expose a cache. And this cache is an interface, and we have an injected implementation available. Metro can discover this automatically. It is annotated with @inject. But the automatic discovery here is technically just a cache impl type, and we need a cache type. So we could add a @binds property in our graph, but we already know at the implementation site that we do want it exposed as a cache type. And this is where we introduce our first contribution type, which is an annotation called @contributesBinding. So contributes binding contributes @bindings for that class as one or more of its supertypes. Under the hood, Metro is going to be generating contribution interface that the consuming graph just ends up extending. If there's multiple supertypes or an ancestor type, you can also explicitly define it. If you're familiar with Anvil, this works mostly the same, except that the bound type is a little bit more flexible. Metro uses this binding semantic here, and that actually allows us to store generic types. We can put qualifier annotations in here. It's not limited to just being a K class. Again, things that we can do since we're a compiler plugin. The compiler will validate all of these at compile time, so that the annotated type extends and implements the bound type, and if it doesn't, it will tell you, and you don't have any surprises. If you have just a single super type, you can also just omit the binding argument altogether, and we'll understand that you're just implicitly using that type. Now, if we want to contribute into a multi-binding, we can do that too. Contributes into set, contributes in a class into a multi-bound set of its supertype. Maps are similar. We just annotate the class with the map key as well. The third and simplest type, or contribution type, is something called @contributes_to. So maybe we define these handlers in some other interface, and we just want to make sure that the app graph eventually extends this. Contributes_to just contributes the annotated interface to that scope, and then the graph will end up extending it in the final compilation. As long as these classes are visible on the class path to the graphs that declare that scope, the Metro compiler will automatically aggregate and include them directly in the graph. This is super useful, if not necessary, when working in a larger modularized code base. Next, let's talk about intrinsics. So, like Dagger, Metro supports injection of bindings wrapped in what we call intrinsic types, namely provider and lazy. These are useful for deferring creation and initialization of dependencies. They only need to be requested at the injection site, and Metro's CodeGen will generate all of the necessary stitching to fulfill that request. Provider is like Dagger's provider. It's a simple interface whose invoke call will just return an instance every time. If the underlying binding is itself scoped, then it's always going to return the same instance that whenever you call invoke. If it's not scoped, then it will return a new instance every time. Lazy is just the Kotlin standard library is lazy. It lazily computes a value the first time that it's evaluated, and it's also thread safe. Note that lazy here is different from scoping in that here it's confined to the scope of the injection site rather than the graph instance itself. There's functionally no difference between injecting a provider or lazy of a scoped binding. The underlying implementation in Metro's double check prevents double memoization in that case. The last thing I want to cover in this sort of prolonged primer is something called graph extensions. If you're familiar with Dagger subcomponents, this is the same concept, but with a hopefully more obvious name. Graph extensions are graphs that extend other graphs, and you declare them with this @graph extension annotation, and then declare an accessor for them in their parent graph to tell Metro to generate them. Like regular graphs, graph extensions can also have factories that you can declare instead. The parent graph can also implement these factories. They can have scope annotations, they can have aggregation scopes, they can have provider and binds callables, and they can also even have their own chained extensions beneath them. Okay, so that was a long primer. Thank you for sticking with me. There's a bunch of neat advanced features that I'll touch on at the end, but I want to pause here and return back to our original example. So let's hop on the build train and follow how Metro runs these tracks in the compiler. First, let's look at a conventional Gradle build pipeline. In the simple case, you just have a compile Kotlin task, and if you're in multi-platform, you'll output multiple binaries. If you run KSP, then KSP is going to end up running first and generate some sources that go into compile Kotlin. And this is sort of what, like, say, the Anvil KSP or Kotlin inject pipeline generally looks like. If you run capt, you actually get two precursor tasks, one Kotlin compile task to generate Java stubs, and one Java C task to run Java annotation processing over those stubs. Then its outputs are piped into the compile Kotlin task. If you have any Java sources, you also get a compile Java with Java C task after your compile Kotlin task. And in a complex case such as Dagger compiler, you can end up with 4 stages in your compiler here. So stubgen, capt, compile Kotlin, and because Dagger generates Java, compile Java. So that's 2 Kotlin compilations and 2 Java compilations. If you use Dagger Hilt, its Gradle plugin actually adds another Java C task at the end, so that gets you up to 5. If you run KSP, that is somewhere in there. And, you know, you got 6. There's a lot happening here, and I don't have room on the slide for a 6th anyway. And that's just one module. So in a modularized code base, this gets multiplied by n number of modules in your project. And this obviously isn't ideal. The large teams will try to mitigate that impact by limiting how many modules, say, like apply capt. This is also a big appeal of Anvil, which allowed you to offload some of this work that the Dagger compiler was doing by its factory generation feature. In Metro, all we ever have is just one compilation. This alone makes it much faster than the above scenarios. And on top of that, it generates IR directly in the compiler, so there's no round trip to generate sources and then compile those. How much faster, you may ask? Well, it's pretty fast, like up to 40 to 70% faster depending on your setup. There's a benchmark project in the repo and also some shared testimonials on the documentation site. But I encourage you to obviously measure and test for yourself too. So let's explore the phases of this compiler. There's two primary phases in the Kotlin compiler. We have the front end and the back end. Each of these have roughly 2 interphases with a translation layer in between. Let's break these down in order and what Metro is doing in each. The front end is focused on parsing sources, reporting diagnostics, and building a resolved front-end IR, aka FIR, representation of the Kotlin code that is ready to be compiled. It's a tree structure representation of the Kotlin code that it parsed. So source files go in, the parser reads these files and loads an PSI representation of them. That's the same PSI that runs in IntelliJ, the same PSI that runs in linchecks, or the linchecks are built with. And this is sort of basic tokenization to build an FIR tree and shakes out things like syntax errors. Once the FIR is constructed, a wealth of checkers actually run over this tree to report diagnostic issues, like literally just hundreds and hundreds of these in the compiler. And because FIR is what's running in the IDE, they show up in the IDE. FIR was introduced in K2 to streamline the compiler front end and significantly improved compiler performance along the way. It also unified the model that the compiler and the IDE ran, making it much easier to introduce new language features. So if you felt like things had sort of slowed down leading up to K2 and things have sped up a bunch since K2, this is a big part of why. The front end is also pluggable. So in K1, there was something called Analysis Handler Extension, which I'm not going to cover here, but it's worth mentioning that that's what Anvil and KSP were built on top of, and why it was much faster than using capped factory generation at the time. This hook was really only for generating new sources, though. Even in Anvil's case, it would generate new sources and then run the front end again for multiple rounds. And it also didn't support custom diagnostics, as far as I know. In K2, there's a fully fledged plugin system for generating new declarations, transforming them, adding custom checkers, etc. And Metro uses all of these. Metro does 3 types of mutations in FIR. We've got declaration generation, we have super type generation, and we have something called status transformation. Metro generates a lot of different types of declarations. Constructor-injected classes or providers get generated factories that graphs call to create instances. Here we end up getting another benefit of Metro. Since we can modify classes and generate classes within them, this is what allows us to inject private constructors, since nested classes can access the outer enclosing classes' private declarations. Assisted injection needs to generate factory implementations. Contributed types generate a nested contributor interface that will host binding declarations, et cetera, graph creators, member injections, a few other things run in here. Most of these declarations implementations are generated later in IR, but in order for them to be visible across modules, they need to be visible to Kotlin metadata. And in order for classes to be visible to Kotlin metadata, they need to be visible at the end of FIR. So we generate header signatures for these classes in FIR, and then we go and implement them in IR. In the IDE, you can also see these generated declarations if you enable IDE support. Supertype generation is a callback that we get during FIR construction to generate additional supertypes onto a given class. This is the hook that we use for Metro's aggregation features. Skimming over the implementation details a bit, but it allows us to tell FIR that these classes should be supertypes of our final graph. Even though these classes may not be implemented yet, just denoting their supertypes is enough to satisfy the compiler here. And a neat new IntelliJ feature is that it'll show these contributed supertypes in the IDE as well. And you can actually even skip doing, say, like SmartCast. Finally, we have status transformers. Status in Kotlin is this batch of modifiers in a declaration. It also includes modality, think like open, final, and sealed, and visibility. Metro has 2 transformers. The first transformer transforms provides to always be private, allowing you to write them without a visibility modifier, but transforming them to be private at compile time. The second adds an override modifier when necessary to an accessor if it was contributed by a supertype that has a matching signature on one of its accessors. FIR generation is extremely finicky. because FIR has life cycles. Remember, this is running in the IDE, so you don't actually know here if, say, a function that doesn't have a return type is intentional or if the user just hasn't written it yet. Metro, as a result, tries to limit what it does here to just the bare minimum. It even does have some features that rely on IDE visible FIR generation, but they're behind flags because it's still sort of new and up and coming in IntelliJ itself. After FIR generation is done, we enter the checker phase of FIR. So checkers are basically helpers for reporting diagnostics to make sure you're holding it right. Think things that are syntactically valid but programmatically wrong. A simple example of one of these is to make sure the dependency graph factory has a single abstract function. That function must return the dependency graph, and that function has to have valid parameters. Metro has nearly 100 diagnostics of this type to make sure that you don't accidentally do the wrong thing and try to bounce you in the right direction. Since this is all in the front end too, they appear really fast and early in the compilation. And again, since FIR also runs in the IDE, these show up right in the IDE. Full IDE support requires a bit of setup, and there's documentation on the doc site. But once ready, it can show diagnostics and even show you generated types like generated assisted factories. I'm going to race through because I am running up against the clock here and there's other people coming in. So now let's talk about the backend. So up to this point, all Metro's plugins have done is create basic headers for the classes and merge contributions. Now we're getting to the fun part, graph generation and graph validation. The Kotlin compiler backend speaks a structure we call IR, and an FIR2 IR phase runs to convert FIR trees into IR trees. In the backend, we then have two phases. IR transformation, where transformers transform IR code across multiple rounds to optimize known programming patterns or generate extra IR code. And then there's an IR lowering phase, which lowers IR code into target platforms like the JVM or native, JavaScript, etc. Each supported platform has their own conversion to their binary format. Metro doesn't do anything in IR lowering, so I'm going to skip right past that and only focus on transformation. At a high level, IR transformation could be thought of as like the implementation details of the compiler. This is the phase that implements the bulk of the code, ranging from desugaring language features that we like to more primitive constructs, optimizing common patterns into more efficient alternatives. It's also a fair bit older than FIR, having gone stable in Kotlin 1.4 or 1.4.3. This is also the phase that Anvil's contribution merging ran in. However, in K2, it's no longer possible to run this in cap stub generation, which is why Anvil is never going to work in K2 with Dagger. Metro's IR transformation runs in two parts. First, it finishes generating those binds functions that we generated in FIR for contributing types. Along the way, we collect some information about all the contributions. And secondly, it transforms everything else. At a high level, I apologize, this graph, or this slide is not very readable, but breezing through here, at a high level, Metro's pipeline in this phase can be described as transform non-graph classes, so simple mechanical implementations for things like factories, and then processing dependency graphs, which goes in order of collecting graph data, like information about its bindings, roots, extensions, etc., processing any extensions first so that we can know if they are using any scoped bindings from the parent graph, building a binding graph. This is the graph data structure within Metro that holds bindings and can validate them. Sealing that graph, which populates bindings starting from the parent's roots, as well as any that the child graphs asks for. Running a hybrid Tarjan plus Kahn algorithm to detect cycles, safe cycles, and perform a topological sort of the resulting bindings. And produces a result at the end with your sorted bindings, the reachable ones, and any deferred types for valid cycles. If the binding graph is valid, then we start implementing the IR graph class directly from it. My clock says 0. How am I doing? Thanks. I'm going to try to go through as quick as I... Go quick? Yeah, all right. All right, so let's go back to our weather app here and see how they're modeled in IR. First, we're going to peel off metadata from the graph, things like the scope, any bindings, etc., accessors. Then we're going to end up plugging this in to a binding lookup so we can go find them. Then we start walking from roots. I'm really breezing through here. once we have a list of all the bindings that we populated from that visit, we plug them into Tarjan's algorithm. This is basically for doing cycle detection, and it gives us nice, clean error reports whenever we have a cycle. If that all passes, then we take the resulting bindings that we have left, plug them into Kahn's topological sort, which tries to sort them, you could think of as the safe order to initialize them, starting with dependencies that have zero, or bindings that have zero dependencies. Once we've got all of our bindings available and we're done sealing the graph, we can start implementing the actual graph. So to decide what fields we need, we have this provider field collector class. Scoped bindings are usually the only things that need fields. Any bindings that are reused, we'll toss into a field for reuse as well. If they're scoped, we wrap it in a double check so that we only ever get one instance, and then the rest of it is just calling through those like generated factories that we had. And then we will go through at the end and implement any accessors for the final graph, and then there we go. Then we have a functional working graph that looks really ugly on here, but the point is you don't have to see it because it's compiler generated. There's some other stuff that I'm not going to get into. There are considerations we have to make for incremental compilation. There are hooks in the compiler for doing this. Metro uses those hooks. It makes it very fine-grained. We also do transformations for these create graph calls that I mentioned at the beginning to turn them into real calls. If validation fails, we try to give you really readable and actionable information, including hints at the bottoms of messages where appropriate to say, you know, hey, like you asked for this, I couldn't find that, but I found one that looks similar. If you have a cycle, it'll also tell you information about the whole cycle. If you have invalid bindings, we have other types of hints to tell you, you know, hey, like this is probably not what you meant to do here, and this is probably what you wanted instead. This is everything I didn't have time to talk about today. Hi, everyone at the door. Adoption, there are docs, you can go read them. Custom code generators, also possible. Migration, also possible. FAQ, also on the doc site. In the future, also on the issue tracker. Thank you, goodbye. Yeah.
Doing the live broadcast, I'm like, Chad, I don't want them to be mad at me.
Yeah, no problem.
You breezed through it though. You got it.
Yeah.
You got it all.
Thank you so much. Because only because of you, we can enjoy more often and enjoy to enroll multi-platform this on the KSP. And you're the first one. Thank you so much. The question, so you mentioned the system protection.
Extend an interface before we write the create method.
this microphone to put this microphone again. Thank you.
It's the entrance baker.
I saw you, you were like, don't worry, because I'm the sound engineer, so if I don't start, there isn't starting. No worry. Could you please put
Yeah.
just to make sure you're number 4. You're
Yes, yes, correct.
So you're going to sit later. So
Yes.
I'm going to put it here.
You don't want to pass it through the
Please
t-shirt?
do not, nah, that's not a good idea.
I'm good.